This conference will now be recorded.
Hello everyone, welcome to our day 24 in our GCP Cloud Architect training. So where yesterday we started exploring more about reserved internal IP address, static internal IP address, static external IP address, and the most important concept was alias IP, which could be very important in the new exam. So speculating, that's it. I have not taken it, but my understanding is it's going to be heavy on networking, so that's the reason we are going so slowly with the networking, so you get the concepts there. Yesterday we had stopped at this slide, so we wanted to see how a cloud VPN demonstration can be done with the constraints which we have. Basically, we have only GCP console, nothing else. We don't have really a infrastructure, an on-prem infra we don't have as an individual. What maximum we can have is basically uh, maybe a AWS instance, if you are AWS subscription or AWS account or an Azure subscription is what you may have. If you want, you can try it. I have tried it once I had an account, so I had tried it. Works actually. But I'm not asking you to, if you're not aware of AWS, if you're not aware of Azure, I don't want you to take any risk, because in AWS, if you make a slight mistake, they start charging you to your credit card. So, but it's not like GCP. So there's a slightly different billing model there. So I don't want you to get uh, charged for the stuffs which you don't know. So that's the reason, to play a safer game, we are going to use two GCP projects. This is mandatory, folks. So you already have one project which you are using every day for the learning purpose. Create one more project and start doing the demonstration there. So that way you will not have any quota issue, and you can do this entire cloud VPN demo on your free trial account itself. Okay, so this is where we had stopped. We had to do a demonstration. Before we get into the demonstration, there are a couple of questions which I did not answer yesterday, so let me answer it first. uh, First and the foremost thing, so I have a virtual machine which uses alias IP, so which has a couple of alias IPs. So if I show you this, this is the primary IP, and you have two alias IPs, range 1, range 2. Now, if I log in to that VM, to save time, I have just already logged into this VM server, this thing. So if I type IP space A, I only see the primary address. I only see the primary address, this one. If I slightly scroll this up till here, so you see 10.5.4.18, but I cannot see my alias IPs. So the command I told, I don't remember the command. So the command is something like this, folks. IP route show table local. So the local routing table, if you see, you'll come to know your alias IPs. So you see 172.16.100.100, 172.160, 192.168.200 dot those things. So you see both the stuffs. So the command which does that trick is this one. So let me just add this in the cheat sheet for your quick reference. In the implementation documentation, I'm going to add to view the alias IP in the VM, use. That's it. So that was the first thing which I did not answer yesterday. So let me just delete that instance. We don't need it anymore, and we are going to do little bigger demo, so we need all those things. So I'm just going to delete this off. Once I delete it, to make the demo simple, I'm not going to have basically the secondary IPs which we created yesterday. So I'm just going to delete that also, waiting for the VM to get deleted. done. So I go to my subnetwork, edit it, simply delete my secondary IPs because there's no VM attached to it, so I can delete it. So then there was one question from Vivek: can the secondary IP be expanded? Like how we expand our primary range from /24 to maybe if you want to make it as slash sorry, if you want to expand it, you can expand it, right? So you can make it as /20. You can expand it. That is possible. Is it the same way? Can we also do the expansion of secondary ranges? Was the question which Vivek asked. I told yes, but later we figured it out it was not possible. And I also saw it in the documentation. And this is an official documentation, so I'm putting it in the chat, and it is very clearly mentioned. CIDR expansion is not supported in secondary range. So it makes it very clear, and thanks Vivek for asking this question. So it's very clear it is not going to be supported. And there's one question which Anil Kumar asked yesterday, so I have not still worked on it. So once I work on it, I'll answer it maybe next week. Okay, so with that, let's jump into our demonstration, which we wanted to do. So we have project 1 and project 2, and there's going to be lots of screens which we are going to show. Basically, VPC, firewall rule, then cloud VPN screen itself, we are going to see lots of things. So there's going to be screen switching happening. To make our experience little better, what I have done is there's a new feature. I guess in other browsers also it is available. I have not explored it, but in Chrome browser you get an option called as groups. Recently added feature, if I'm not, it's Chrome browser feature. So what I have done is I have 6 tabs open. I have grouped 3 tabs under one called as project 1. So if it's yellow color, it's all project 1, so that you will not lose track. Everything is going to be project 1. If I see anything in pink, it's all project 2. I have grouped my tabs. Tab grouping is a feature name, if I'm not wrong. So what we are going to do is to set the context. In project 1, yesterday itself we saw the VPCs are there. VPC Taiwan, VPC Singapore, both are having firewall rule which is open, pretty much open to the entire world, where you can do SSH and ping is what we have seen. The firewall rule wise, everything is pretty open. VPC is there. Then if you want to see the route, we will also see the route, and then go ahead and create a VM. So if I just click on routes in my project 1, so if I click on network VPC Taiwan, so I get basically only 2 routes. One is the internet gateway, the other one is your local route. Anything in dynamic, nothing. Anything in peering, nothing. So this is the current state, folks. Similarly, if you go to your project 2, where there's only one VPC, so if I go to my routes, you will see 2 routes as usual, the default one and the local route. That's it. So this is the current state which we have. So under dynamic, nothing there in project 2. Peering also, there's no routes under project 2. So far is the context clear, folks. So where we are in, what is the setup which we have. So what we have skipped already is VPC creation. We know n number of times we have created, so that I have skipped. Firewall rules also we have created multiple times, so that is also I have skipped. Now what I'm going to do is I'm going to create 2 virtual machines, one which is going to use VPC Taiwan, one which is going to use VPC Singapore. And these VMs will not have an external IP address. We'll have only internal IP address, and we'll see whether they can communicate. We are very much sure because they fall under 2 different networks, they will not be able to communicate. But instead of doing a VPC network peering like what we did in last class classes. We are not going to do that, but we are going to see cloud VPN setup, because cloud VPC network peering is non-transitive in nature. Cloud VPN is transitive in nature. You can do A to B, B to C, and A to C. That is possible. So only because of that, some organizations prefer this kind of an architecture. So let me create VM in project 1, call it as server Taiwan, and create a VM in project 2, call it as server SG, and see whether we can ping it. So I'm going to use project 1, it is in yellow color tab. So create a VM. So use a template, because project 1 is nothing but our batch 6. I just renamed it yesterday so that we can relate it with our architecture. So I'll call it as server Taiwan. Everything should be good. Under networking, I'm going to use server Taiwan. And the most important thing is I don't want an external IP address. Going forward, we will not use external IP address very heavily. So done. Click. The VM should get created. So similarly, I'll go to my pink color. Hope it is pink. I'm not able to get that color very clearly. Or purple, sorry, purple. So I'm in project 2. So let me create another VM. So I'll call it as server SG. This is in 2 different projects, but in the same account, which is learn GCP 2028 user. So I'll call this as server SG. I don't have a template in this project, so I have to fill it. Everything default service account, everything is default. So because there's only one VPC, it is already set, so nothing to be done. Make your external IP address none. Create. So by the time this VM gets up, I'll go to my project 1. There's already a VM. It is very clear it has only internal IP address. It has no external IP address, and it belongs to VPC Taiwan. Click on SSH. By the time that SSH happens, I'll come to my project 2, and let's see whether the VM is there. It is there, and this is possibly a known bug, folks. If a VM is having internal IP address, you will see SSH grayed out. But if I go to my details of the VM, the SSH is going to be allowed. So you see that it is allowed. If I go back, it comes up. So looks like there's a bug. It was not like this in the beginning. So off late, I see this issue. So maybe refreshing the screen can help you out if you are the owner of the project. So just a known bug. Maybe they are working on it. The Google team is working on it. Okay, let's wait for the screen to come up. As usual, standard procedure. By just doing ping itself, we have learned lots of concept. Again, the most complex networking stuffs like VPN also, cloud VPN also, we are going to learn with the help of ping only. So I'm going to copy the IP address of server SG and ping it, and I'm not going to ask you whether it's going to work or not. Everybody knows it's not going to work because they are in 2 different networks. We have learned this. We have learned it. So it's not going to work. It's not going to work. The fix this time which we are going to use is not cloud VPN network, VPN network peering. We are not going to use that. We have already used it. So we wanted to learn something new. So that one is going to be using cloud VPN. That's what we are going to use. Okay. So we'll see Cloud VPN in action. Okay, so how it's going to work. So let me also put it here so that it looks good. So once the VPN is set up, things should start working. At the end, what is this going to do, folks? Simple. It's going to create a route. That's it. As simple as that. There's going to be a route which needs to be created. Even in our network, VPC network peering, we saw two networks not communicating. When you enable VPC network peering, the route was getting created, called as peering route. That's it. Cloud VPN is also going to do the same thing. Nothing difference. So the route is there. That's it. It just treat two networks as two different cities or two different places where there's no connectivity. You are having a road built or a bridge or a flyover, whatever it is, you build it, then people commute between these two cities. That's the same thing which you are going to do here. So people are going to be your packets here. So that's it. So if that concept is very clear, things becomes very, very easy. So it's not working. The solution which we are going to use is Cloud VPN. So for that, we have not done anything in this architecture except the stuffs which is already there, the VPC firewall rules. Now what we are going to do basically is we are going to first create a gateway. For a gateway, you need to have an external IP address. This is going to be a external IP address. So this is how, because the communication is going to be via internet, you need to have a public facing presence. So you're going to create a gateway in Taiwan, a gateway in Singapore. So this has to be an external IP address. So meaning we have to go and reserve an IP address. So let's try to reserve an external IP address in Taiwan and call it as Taiwan static IP. Similarly, in VPC Singapore, we'll call it as Singapore static IP. Okay. So I'll keep this tab. This tab also I'll keep. This tab we can use it if I want. So 3 tabs I have opened up just for easy navigation. And could be a small tip here, folks. When you're showing some demonstration to the customer and there's a concept like this which needs to be shown because they are not aware and they wanted to see a proof of concept, don't open one tab and play around with it. Have something like multiple tabs like this, show that, because sometimes, right, the screen loading, all those things is going to be a problematic thing. So if you're showing it to some senior person who can only give 30 minutes of his or her time, you want to use the full stuff. Just don't ideally be sitting there waiting for the screen to load. A small tip basically. um, if I just go to my external IP address, I don't want to wait the loading of the screen basically, so it should be little fast. So let's reserve an IP address in project 2 and we'll call it as Taiwan static IP. And yesterday itself we have seen, if you don't use an IP address, it's going to be charged heavily and it's going to be charged hourly rate. So I'll call this as Taiwan static IP. And IPs can be either regional or global, the IPs. So in this context, we are going to use a regional IP address. Global is going to be when you are using load balancers. So we'll talk about load balancers in today's class itself once we finish this VPN part, and a demonstration on load balancers in next class. Okay, so the one which I wanted, I'm just going to leave stuffs which is default, not going to touch. So let the network be network service tier be premium. What is that? We'll see as we go progress. So this is going to be a better option where your packets spend more time on Google network basically. So we will do this, and there's also a demonstration in my channel. If you search for premium tier, you should get that. We'll do also that in our class, but in the coming classes. So two types of versions, so IPv4 and IPv6. If it's going to be regional, better to use IPv4. So I'm going to use basically Taiwan, and I'm not going to attach it to anything. And you can really see the value of Google being very transparent in their pricing. where they very specifically mention static IP addresses not attached to an instance or load balancer are billed at an hourly rate. If you attach it, it's going to be per second billing, per second. So this is to avoid reserving and not using it. So yesterday we saw this, right? Because the number of IPs which you have is limited in the entire world. So the population is more than that. So to avoid this practice, they do this. So reserving an IP address, want to see the command line equivalent, make this as a habit, folks. So G-Cloud Compute addresses create. That's it. And this is a regional resource. Click on create. Let me see whether we have added that IP details. No, we have not added. Let's add this. What should I call external IP? So it can be global, regional. Global we had seen in our load balancer. We'll see it one more time, or it could be regional. Just a small update. We'll keep on updating it as we progress. CloudNet we will discuss today. Okay. The IP address is provisioned, folks. Now the key part is if you see something like this, the billing is already started hourly rate. It's going to be at an hourly rate. So it should be attached quickly to a forwarding rule. Okay. So currently it is like this. Now the IP address given to us is this one from the pool. From the Taiwan pool of IP address. Now to make the demonstration little easy, yes, we can switch to screens and get it, but I'm going to create a small reference material where I can copy all this information into a notepad so that I can refer back to this notepad very quickly whenever I want something. So I'm just going to create something like this. So I'm going to call my small material, that's it. Cheat sheet, you can treat it as. So Taiwan static IP is going to be this one. That is what we got. Similarly, if I do the same thing to in my project 2, I go to my VPC external IP, reserve a static IP address, call it as Singapore static IP. Same, I'm going to leave everything as default and I'm going to use Singapore, and the same warning is going to be shown because you have not attached to anything. So reserve it and let's see what's the IP which is going to give. Should be 35 dot something or 34 dot something. So done. I'm going to add this here, Singapore static IP. And what are these things basically? These are your VPC Taiwan's CIDR range, VPC Singapore's CIDR range. So if you want to see VPC Taiwan's CIDR range, Singapore CIDR range, I just made a note of it. That's it. So it's the same thing. I guess, hope it is. Yes. Singapore's is 10.1.3.0 and Taiwan's 10.5.4. So 10.5.4. So this is going to be helpful. That's the only reason. So far, what we have done as per the architecture, we have the gateways, which is going to be used as gateway. We have reserved the IPs. Now, the next thing is we are going to create a tunnel. So we are going to create a tunnel and it has to be created from both the sides, but it's only one tunnel, folks. It's only one tunnel. Okay. One tunnel configured in both the sides. So for that, I'm going to use my first tab under VPC network, which is bookmarked or pinned. We don't see any option called Cloud VPN. So basically you have to scroll down to the main menu, networking. So under networking, if you see some of the stuffs we have already explored, except couple of them which we have not explored, serverless VPC access and packet mirroring. So we'll look into that as time progresses. So because this is connectivity between two networks, right? So they have added your cloud VPN stuffs under a category called as hybrid connectivity. Hybrid. So it could be GCP and GCP and non-GCP networks like on-prem or other cloud. So they have added it there. So that's where you see VPN. So I'm going to use this heavily. So I'm going to pin this so that I can avoid some navigation delays. So hybrid connectivity, click on VPN. Now, VPN, a virtual private network, lets you securely connect your Google Compute Engine resource to your own private network. Google VPN uses Internet Key Exchange version 2 to establish IPv6 connectivity. So, or IKE version 1 or 2, depending on what's your on-prem network, you choose. This is basically a protocol, basically Internet Key Exchange protocol. How the keys gets exchanged, two networks are going to communicate. So there's going to be some kind of a secret which is going to be shared, a shared secret. So to exchange it, they use a protocol. So these are more of networking concepts. If you are really interested to explore how IKE version works, how border gateway protocol works, I would strongly ask you to explore some more networking materials. And these are generic networking concepts, folks, nothing specific to GCP. What is IPv6, which is nothing but VPN. Uh, and IPv6 is going to be at your layer 3. So if you remember, go back to our basics which we saw. Basics. So basics, network layer, you see IPv6. This is what we are going to see. This is ICMP, we have seen it. IPs, we have seen it. All things are at layer 3. So if I just go back to my cloud VPN, the tunneling which is going to be is done is at network layer. So sorry, at network layer. I would strongly suggest to read each and every words which they give, because some stuffs are really going to be conveying a lots of message. Now let me click on create VPN connection. Now when I click on VPN connection, you get two flavors, folks. Two flavors. One is called as high availability VPN, in short HAVPN. The other one is called as classic VPN. The diagram itself is little intuitive. So if I just zoom this, so if you see basically HAVPN, it says there are two tunnels, tunnel 1, tunnel 2, between your on-prem and the GCP network. Classic VPN basically has only one tunnel. So if I just zoom this off, in our demonstration, we are going to learn classic VPN. Why? The only reason is classic VPN supports two types of routing called as static routing and dynamic routing. So we wanted to learn that part. So we want to learn what is dynamic routing, what is static routing. Why we are not using high availability VPN? Because it only supports dynamic routing. So if you only do dynamic routing, you'll never understand how static routing works. At least your understanding should be there, right? Maybe for a quick proof of concept, you may go with static routing. What is that? We will learn by doing a demonstration itself. So for the demonstration purpose, we are going to use classic VPN, and it's not HA, because only one tunnel. If one tunnel goes, the connectivity is lost. But in your HA, there is going to be two tunnels, redundant tunnel. So one tunnel goes, still the communication is going to be established. So, but in production, when you are doing this, it's always recommended you always do it with HAVPN, because you're going to get a slightly higher SLA. So your classic VPN is going to be only 3 nines of SLA. Your high availability VPN is going to be basically 4 nines of SLA. So you have a better SLA there. So for our learning purpose, because we are doing it for the first time, I wanted to take classic VPN. So continue. So classic VPN screen has come up. So this screen is divided into two sections. One is your VPN gateway. The second section is going to be your tunnel. So first let's fill the VPN gateway section. So I'm going to give a name which I can remember very properly. So this is I'm doing in project 1, which is basically for our VPC Taiwan. So I'm going to call it as VPN Taiwan gateway. And don't mention it like VPN 1, VPN 2. You'll never learn what is this, because first time when you're doing, give a name, better name, so that it's going to be very clear. So this is from the Taiwan VPC. So select your VPC, which is VPC Taiwan, and the VM which you wanted to connect, the subnetwork which you wanted to connect basically is in or the sorry the sorry not the subnetwork. The gateway which you have reserved, if I just go here, it is in Taiwan region. So select the region. So if I just mouse over, it's going to show me this is the region where the gateway of your compute engine is located. The tooltip really helps folks in the beginning. So just mouse over on each tooltip and then see it. So where is our region? It is in Taiwan. And the moment I select that, I automatically get that static IP which I had reserved, because the region we have already used it, like we have already created it, right? It shows up. You can also create it on the fly, but I wanted to show you how we do in a very systematic way. You create everything and do start it. And this is slightly a complex demo, so I thought I'll do it in a systematic way. So added it. That's it, folks. That's the configuration of your gateway. So simple. Just give a name, select the region where your gateway is created or reserved, and use that IP address. That's it. Job done. So scrolling down is the major portion. The tunnel creation is the major portion which you need to do. So let's give a name to this thing. So I'm going to call it as Taiwan VPN Taiwan hyphen tunnel hyphen 1 is very important. Why? Because you may have a second tunnel for redundancy purpose, and I have seen this as a practice. They put hyphen 1 hyphen 2, so that's a good practice, so that it gives an indication that it's going to be coming. One more tunnel may come, but for gateway we are not going to put that. It's going to be only one gateway. Okay, so that's the name. Give it. Now peer remote peer IP address. If you don't understand it, no problem. First of all, it's remote and peer. So this is where the tooltips are going to really help, or the help option. So the public IP address of your own network's VPN gateway. Now the assumption is you're doing between GCP and on-prem, and that's the reason they have given that. So the public IP address of your own network's VPN gateway. What does this mean, folks? Remote peer IP address. What is this referring to in our context? Anybody wants to comment? What is this? Maybe you can put it in your private chat. What is this referring to? The public IP address of your own network's VPN gateway. What is this referring to, folks? Yes, Mangesh, that's correct. Anybody else? The tooltips helps basically. Yes, Anil Kumar, that's correct. I'm just going to give you 30 seconds and then we'll move on. Anybody else? It's basically in our project 2, the Singapore static IP, which we reserved. For Taiwan, the remote is Singapore. For Singapore, the remote is Taiwan. That's the simple stuff. So this is the IP address which it is asking. Either you come to the console, copy it, or use the cheat sheet which we have built already. So remote peer IP. So which is Singapore's IP address, the gateway, Singapore's gateway, mention that. That's it. Simple. Now moving on to the next thing, this is the most important thing. So if I just mouse over, Internet Key Exchange Protocol version. So for establishing the connectivity and for sharing the secret, which we are going to see in the next few minutes, is going to be using two versions. So this is going to be really important. When you are connecting between GCP to GCP, you can use the latest version, no problem, because GCP supports both the versions. I guess 1 year back or 1.5 years back, AWS, the so-called the number one cloud provider, was still providing IKV version 1 only. Recently only they started providing IKV 2 version support. So that's a point to be noted. And why this is important is, if you are connecting to your on-prem and your on-prem network is little old, so they don't support the latest version, then you have to use IKV version 1. You're forced to use. So it should be the same protocol. So make sure you get this information when you are doing a real implementation, that between between on-prem and GCP. Ask them what is the key exchange version, internet key exchange version, which is going to be used, and you have to fix to what they are using. If in on-prem they are using version 1, you are forced to use it. Okay, so we will use version 2 because we are going to use GCP. Then there's going to be two networks. They are going to have a shared key. Only if the keys are same, the communication is going to be established. So you can give a key like batch 6, as simple as possible. Or to make it little complex, what you can do is you can generate a 1. And this key is going to be shown only once, folks. You have to make a note of this and keep it in a secure place. If you lose it, you have to regenerate it, basically. So if you want, what could be the possible choice to keep this key, folks? Where we can keep it? Any possible options in GCP to keep this key securely? No. No. Yes, Anil. The name is slightly different. Half of the answer is correct, Anil Kumar. Couple of wrong answers. I have a key, folks. Where will I keep it? Mm, you are there, but the actual name is slightly different, Anil. Secret manager, folks, not KMS. Please remember, we have done a demonstration on KMS. That is only for your encryption keys. Please remember, it's not KMS. Don't get confused. It's secret manager. Or if you want to keep it outside of GCP, HashiCorp Vault. So secret manager is the important thing, folks. Okay. So you can keep it in secret manager if you want. So the key is generated. Good. Now what we saw, we enter the remote peer IP address, choose the latest internet key exchange protocol version, generated a key, and if you want to still make it more strong, the trick which I use off late, I'm using this kind of a trick. Cut that, generate it one more time, paste this. Now my key is little stronger. If you want, you can do this. Or in some organizations, when I do this implementation, I do it 3 times. A very strong key. So the total content is going to be something like this. This is my total content. So very secure, right? Very difficult for someone to predict this. So this is something which you can use. You can use an inbuilt tool there. So you can also use this as a password generator. So that's a good one. So I have made it little complex. The key, this is what is expected in production. Now there are different types of routing. Now this is where the time actually has come for us to explore more on routes. And there are going to be different ways of routing here. Dynamic routing, policy based routing, route based, all those things. We'll start with the most simplest one, route based. Route based, where you just mention the remote network IP address range. So for Taiwan, what is the remote? Singapore. So if I just mouse over here, one or more IP ranges in the CIDR notation that defines the peer network. What is the peer for my Taiwan? It's going to be Singapore. So go to your Singapore, get the CIDR range is what they are saying. So let's copy this and paste it. This is one network. If you have multiple networks like this, for example, just giving an example, folks. If you have more networks, you can put it. It is possible to put like this. This is possible to put like this. So since we have only one CIDR, I'm going to put only the one. Done. That's it, folks. That's it. So the tunnel is going to be created. The first tunnel is going to be created. So you need basically, you need the actual, you should know what is a VPC, the remote peer IP range, which is your Singapore's VPC range, the subnetwork CIDR range, the static IP which you reserved. If you know these details, you're going to generate anyway the key. So you should be able to create a tunnel in one side, on the Taiwan side. So that's what we have done so far. So gateway was created. We are not clicked on create yet, and your tunnel also created. Now you have to do the same thing on the other side in project 2 for this to have the connection established. That's it. So once we finish this demonstration, we'll come back to do dynamic routing, dynamic BGP. So next demo is going to be on that, and it's going to be an assignment for you to explore what is policy based, and you let me know what is policy based routing, which you understood after looking into the 2 demos which we are going to do. So out of 3 types of routing, 2 I am going to do, 1 you are going to do, so that your exploration becomes uh, increases your exploration part. Okay, click done. Now I can add more tunnels. I can add more tunnels. So that is where that option 2 mentioning that is going to be really helpful. So I'm not going to create too many tunnels because I have a quota limit. So I'm going to create one gateway and one tunnel. That's it. So before I click on create, click on the command line. So click on the command line. Now you see you just created a gateway and basically a tunnel. 2 commands is what you would have expected literally, but there is 1 2 3 6 commands, 6 gcloud commands. What are those things? Let's explore it. So first command makes it very clear: target VPN gateways create. It creates a gateway. Beautiful, good. Then the remaining 3 are forwarding rules. In very simple terms, if I were to give you an explanation for forwarding rules without getting into the jargons of terms, let's take a simple example. So you need to commute again from your home to office. um, your apartment gate opens. That's the firewall rule at your apartment. So then you get into the road. So when you start driving on the road is going to be your route. So you have a road, it could be a highway or it could be inside the city. So then when you start traveling, right, you'll have navigations. Maybe there are certain places where you need to take a left turn, a right turn, and you may need to take a U-turn. So those I can treat it as my forwarding rules. Now you give a guidance how the packet should be routed. Use the help of your forwarding rules. So there are standard 3 forwarding rules which is going to be used wherever you create VPN. So, and those are protocol ESP, uh, and couple of UDP protocols which is on port 500 and 4500. If you want to explore more on this, I would say that Wikipedia is a good material on what are these protocols basically for. So this is standard. Even if you do it in Azure, even if you do it in on-prem, even if you do it on AWS, it's going to be 3 forwarding rules needs to be there. So I'm not going to do details of this part. So explore it. So this is standard one. So this is nothing specific to GCP. So this is specific, this is generic to all VPN setup. So this is 3 forwarding rules, which is going to use basically the gateway. You see the target gateway. So meaning once I have this forwarding rules, what's going to happen is once we finish it, the in use by currently it is none. It's going to be showing it has been used by 3 forwarding rules. This external IP address is used by 3 forwarding rules. That's what it's going to show. And the last but one is basically going to create a tunnel. It's going to create a tunnel for us. And the 6th one, I want you to answer it, folks. I took the difficult one. I'm going to give you the easy option. What is this 5th one trying to do? Oh, sorry, the last one which is going to do. Yes, Anil Kumar, that's correct. Others, what is this last command trying to do? Yep, that's correct. I got answer from Anil Kumar. Others, what is this command trying to do? We are in a good position now to see by just looking at the command, we can say what it is trying to do. Yes, Deepak, that's correct. Absolutely correct. Anybody else? Yes, Mangesh, that's absolutely correct. So basically, it is creating a route, folks. Simple. It creates a route. Route creation will have certain parameters to be given: priority, your destination IP range, what's your next hop from this to next, what should be my hop. Those details are going to be provided. So first time we are seeing a tunnel, sorry, a route creation. We never saw this actually, so we are seeing it. That's it. So let me now go ahead and create my gateway and tunnel. So it's going to take a couple of minutes for it to finish it off. By the time it finishes off, I just wanted to show you this part. So you see currently it is one forwarding rule added. One more time if I refresh, second forwarding rule added. Third time when I refresh it, it should show up the third forwarding rule. 1, 2, one more forwarding rule should be added. Yes, all 3 forwarding rules. Now my billing is going to be per second. So it's not going to be charged at an hourly rate. So I'm using it. So it's been attached. It's been attached. Default, it's not, yeah, any VPN setup when you do, it's going to be 3 forwarding rules. Standard. It's always standard. Okay. So let me see whether the gateway is created and the tunnel is created. Gateway still showing. Okay. The gateway is created. And if I see the tunnel, it is also created. It's in classic mode. Forget about this BGP stuff. We are going to talk about that soon. The type of routing which you have taken is route based. The handshake is pending. So from the peer network, you have to do a handshaking. Only then the packets can be communicated. So that is currently pending. So if I just go back to my terminal, it is going to be still not complete. So I have to do the same process which I did in my peer network, which is my Singapore. So let me just do this. So go to my project 2, the purple one, go to hybrid connectivity VPN, create a VPN. I'm going to use classic, continue. So I'm going to call this as Taiwan, sorry, Singapore gateway. Only one network, and the region has to be Singapore because that's where I have reserved my gateway. So if you select something else, right, it will not show you because it's a regional resource. So I'm going to select back to Singapore. Done. I have my gateway done. Now similarly, let's do it for my tunnel. So I'm going to give a better name. So Singapore tunnel. The peer for this is going to be my Taiwan's static IP address. So either you can go to the screen and get it, or we have already created a reference. We can easily use this. Please use the same version, IKV version 2. Now the password which you, or the secret which you gave, should be the same thing which you gave in the other side. So we have made a note of it. We could have also kept it in secret manager if we need. So I have this thing, little complex one, shows something which we are doing it is at a production grade. That's good. So I have copied it. Now route based is what we are going to take, and we are going to mention the peer network IP, which is nothing but VPC Taiwan's CIDR range. So you can go to the console, or basically take it from here itself. We had already made a note of this. So you really see the value of putting the small cheat sheet during the class. That's it. Same thing, exactly done. So I'm going to click done and click on create. The moment I click on create, right, I'm going to jump back to my terminal to show you that communication is going to be established. Okay, so click on create. So let's wait for a minute here for our communication to be established. If the connection is established, you will see basically the ping will start working basically, and no changes in your firewall rule. So firewall rule is needed for CIDR range, right? The firewall rule basically to ping and SSH is already there. Ping from anywhere from the world and SSH is already there. I showed you yesterday. I will also show you once we finish this demonstration. Firewall rule perspective, no changes. Basically, if you want, you can tighten it. But it's the prerequisite for it, right? Basically to ping two networks, that's it. So now you see the ping is working, folks. So ping is working. I'll talk about more about firewall rule in a minute. So firewall rule, it's working. So the ping is working, beautiful. If I now go back, see my tunnel and the gateway. So in my project 2, which is the Singapore one, so the tunnel gateway is created. And if I see the tunnel, it is also there. It shows the connection is established. The tunnel is up and running. So similarly, if I go to my other project, if I just refresh the screen, this should also show established. Let me just do it. Established. The handshaking has happened. The connection is established. Now packets are getting routed. So good. Now let me talk about couple of important stuffs here. A firewall rule, set of firewall rules, plus basically your routes. What is that which made this entire stuff work? First and the foremost thing is going to be firewall rule, route, and lastly, hope I don't forget it. I wanted to show you the entire communication is not using it takes a route outside. It takes the internet route. That's what a VPN does usually, right? So your VPC network peering takes basically uses GCP, right? It uses the GCP network, but Cloud VPN takes a route of on like it takes public internet. I wanted to show you that also. So first thing, let me show the firewall rules. Firewall rules. So if I put a filter on firewall rule VPC Taiwan, what I have VPC Taiwan, I have only one firewall rule, which is basically to do the communication SSH and ping, nothing else. So if you don't want 0.0.0, what you can put is the source IP of your Singapore, you can put it. Similarly, on the other side, you can put the source IP of uh, the Taiwan, and you can do that basically. So just to show you the ping stuff working, I have used this firewall rule, Mangesh. Hope it is clear. So if you don't put it, you cannot SSH, you cannot do the ping basically. This is the first part which I wanted to show. The second part which I wanted to show, maybe I can show the firewall rule in the other side also. So if I just go here, firewall, So firewall rule same, nothing difference. Ping and SSH. Now the most important thing which we need to see when it comes to cloud VPN is the routing. So for that, I'll come back to my project one, click on routes. Click on routes and put a filter because there are lots of routes. I'm going to put a filter on the network VPC Taiwan. So now you see basically before you did it, there was only two routes. And you also people were able to say that the last command in that tunnel creation and the gateway creation was nothing but a route. So you see that by yourself, there's a route created in project one. And if you see this destination IP, what is this destination IP, folks? What is it trying to refer to? This IP address or this CIDR range, to be very specific. What is this CIDR range refer to? This is nothing but your Singapore's CIDR range. So if I go to my project 2, this is nothing but my CIDR range. So this is my destination IP. That's it. So this is the route which it creates. By default, whenever the route gets created, it's going to be with 1000 as the default priority. That's it. So I have to turn on my secondary mode. Just a minute, folks. My secondary monitor got off, so I'm not seeing your messages. Okay, so now the route got created. That's the key part. The communication is getting established. We saw about the firewall rule. We saw about the route. Now the connectivity, to very much clearly understand this entire communication. So if you take this, so the entire communication is using public internet, or is it using internal network? Let's verify that using the testing, the network testing tool which we have. We'll verify that. So I'll go to my project one. I'll go to my network intelligence connectivity test. So we had seen this with our network peering. So when we saw our internal IP, we really understood the communication is only using internal network only. It was never leaving Google's network. We had made it very clear. So even it is still there. Server SG to it goes to the firewall rule, the egress, then the peering route comes into picture, then it reaches your server Taiwan. Very clearly there. But when you use external IP address, we saw it was taking a public internet route. The same thing is what is going to happen when you do the demonstration using internal IP address. Also in this case, it's going to be using external IP. It's going to take the internet route. How? Let me just show you. So I'll call this as cloud VPN test. So I'll just use ICMP ping. So the source is going to be my internal IP address of my Taiwan server. Mention it. Good. It identifies this looks like an RFC 1918 standard. Is it in this project? Yes. If it is in this project, please let me know what is the network. So I'm going to mention it is in VPC Taiwan. Good. Then what's the next part? The destination. So the destination is my Singapore's IP address. Copy it, paste it here in my destination IP. It again captures, looks like it is an RFC 1918 standard. Is it in this project? No, it's not in this project. So I'm going to select my project 2. Done. In my project 2, what is a network? It's not reflecting. Okay, I have to choose this. Is this is slightly confusing. 1 minute. I have to use project 2 here. Okay, there's a slightly change there, so I have to select it. Okay, so what I have done basically, my source is my Taiwan machine ending with 19. And I have mentioned all the network details about it, the project details, and my destination is my server SG. I have mentioned all the details. That's it, folks. Now, when I click on create, even though the communication is between these two is going to be internal IP, is what you are using, the entire map or the progress, if you see, it's going to take public internet, the entire stuff, because it's cloud VPN. So it's going to always leverage internet to do it. Let's see whether it's going to be reachable. Yes, they are reachable. We know that by ourselves, but we want to see the entire map. What was the route it took? So first, from the server Taiwan, firewall rule is open. The default egress firewall rule is open. Then it comes to the static route. What is that static route which you created? This is the static route which you see here. If I just go to my routes, put a filter on network. This is that static route, folks. This is the static route which is using it. So route works. After the route does, it goes to this. You see this icon? It goes to your VPN Taiwan Tunnel 1. Then it reaches the gateway, public. Then it comes to the default the route, which is the default one. Then it reaches server SG, checks whether the incoming traffic is allowed, packet delivered, packet delivered. So is this part clear, folks? So even though the communication between your VMs is using internal IP, the entire thing used public internet to do it, public internet to do this. But with our cloud VPC network peering, it was totally on Google network. That's the huge difference between these two things. But VPC network peering is non-transitive. This is transitive. So you have some difference there. So wanted to show you this part very clearly. Is this part clear, folks? The VPN, that to the static routing which we did. Any questions on this? Any questions on this? Okay. No questions. Now, there's a small assignment. I would strongly suggest you do it, but I'll never go and ask you whether you have done this. As a self-learning thing, what you can do is any documentation you see, cloud VPN, basically, when you set up, you can get maximum from 1.5 to 3 Gbps is what you can get, is what you usually mention in the documentation. We are also uh, Yes, Deepak. VPN uses, it's always the communication is going public internet, but it is encrypted. The connection is encrypted. That's where you use those key exchange protocol, the secrets, all those things. No middleman attack is going to happen. So coming back, VPN, when you see in GCP, 3 Gbps is the max which you can see. Now, a small assignment. There is a tool which you can use called as iPerf. So if you just use this tool, right, it's a tool for network performance measurement and tuning. So you wanted to know what is my bandwidth supported. Is it 3 Gbps really? What Google says is 3 Gbps, right? Give a check, explore how to use iPerf. Make one as the iPerf server, maybe server Taiwan, and the client server SG, and do the command and see how much bandwidth do you get. How much bandwidth do you get? You will never get 3 Gbps. You'll never get 3 Gbps. Why I want you to explore it. I want you to explore it. So there is something which is going to have also an impact when it comes to the network bandwidth. What is that? You need to verify it. No need to give the answer right now. So think about it. But that's not the answer, Anil Kumar. So think about it, give a try, explore it, and see what is the thing. And this has a connect to our virtual machines. This has a connect to our virtual machines. Basically, that's the hint. So do it as a small activity. Okay. Now, what we did was a static routing. Static routing. So something like this. Something like this. So you had a specific network, you had a gateway, you took the route of a cloud VPN, it was communicated over public internet. On the other side, you have on-prem. And in on-prem, you have lots of huh, what you are mentioning, Anil Kumar, that's correct. So you have to, yeah, what you are saying is on that lines only, on that lines only. Now, what we did exactly was the static routing, folks. And this was a screenshot which I took it from the official documentation. Now, this is all good. The static routing looks all good, basically. Uh, but the problem with static routing is, assume you're on-prem, uh, you have lots of racks. So your CIDR range for those racks, new rack is added, rack 30. So rack 1 to 29 you have already added in your route based. You added 10.0.1.0/24, n number of things you have added it. Now all of a sudden a new rack has been introduced in your on-prem. Now meaning a new CIDR range is going to be there. So for this to be updated or the communication to be established, basically you have to have some stuffs to be done. It's not going to be automatically communicated to GCP. GCP will not even know there's a new network or a CIDR range added. So they are not going to get that information automatically. That is the reason it is called a static routing. So static routing is going to be really helpful in an organization where the number of times you add a new rack, do any modifications on the network is very, very less, once in a year or once in 6 months. So the network topology is very, very stable. So in such organization, static routing is a good choice. Straightforward option. You don't need to do much. Straightforward. I guess with the explanation itself, we were able to do it in 30 or 45 minutes. So if you have a script, in 5 minutes, you can have this basically. So a straightforward option. But the big drawback is if your organization adds every week or every month a new network, then it's going to be a problematic thing. So the network engineer cannot do always go keep on updating it, all those things. So to answer that, you have an option called as dynamic routing. Using dynamic routing, you can address this. So it's one-time setup which you do basically, where if you use a component called as cloud router, which is a product, which is an offering in GCP, you will be able to address this very, very easily. So new networks added remote is going to be automatically advertised. How this is going to happen, we'll see once we come back from a break. So let's take a 10 minutes break. Once we come back, we'll explore this concept and do a dynamic routing demonstration. Okay, so let's take a break and come back. So let me stop the recording.
This conference will now be recorded.
So before the break, we saw how static routing works. And I just gave a small intro about the dynamic routing. Now, before going into the details of dynamic routing, right, let's go back to the slide. Static routing slide itself. Understand the real pain here. The pain here is new routes, new networks, subnetworks added. It's going to create a problem. So we'll see this by doing actually in our setup itself. So we can treat this part as our project one, which is Taiwan, this part as our Singapore. So if I just go back this part, now what we will add is we'll add a new subnetwork. We'll add a new subnetwork and see whether VMs using that subnetwork can interact with server Taiwan, and we'll see whether it's really going to work or not. If it's not working, what is the step usually a network engineer does is what we wanted to see. Okay, so let's do this part, then you will really appreciate dynamic routing. So for this, what I'm going to do is, first of all, yeah, I'm in VPC Singapore, so I'm going to add another subnetwork, folks. Add a subnetwork, let it be in Singapore itself, and call this as subnet. I'll just copy this IP. I add a next subnet is going to be +1 kind of a stuff. So I'm going to do subnet SG2 and let it be in Singapore itself. So I have some more requirements. I'm expanding it here. So Singapore, and I'm going to add the range like this, +1. So that's it. Add it. My second subnetwork is created, meaning I'm expanding. Something very similar to what this diagram shows. The network is expanding. We have also expanded it. Let's create a VM in there, in that subnetwork. So what I'll do is I'll go and create a virtual machine in this, meaning it's going to be showing as 10.1.4.2. That's going to be the IP address, because the first one is going to be already reserved by the gateway. So your next IP is going to be allocated for the first VM which you created. So let me create this one. Server-sg2 Singapore. All the same except one change is I'm not going to use subnet SG. I'm going to use subnet SG2, because in the same region you have two subnetworks. So I have the luxury of using any one of them. So because my region is set as Singapore, so I'm going to use SG2. Click done, create. Let's wait for it to come up. Okay. Oh, I should not have added an external IP address. Sorry, my bad. We don't want, I forgot that. Sorry. That has no connection to this demonstration, but we'll make it as a practice. At least going forward, we'll not have. If you work under an organization and if they have put that organization policy, that's going to be easier. But since I'm using a free trial account, so I cannot have an org node. I cannot put that restriction. So I have to do it explicitly or use a template every time. So sorry about that. Let's just wait for it to come up with no external IP address. Done. Good. So you see the VM has come up. Let me SSH. Let me SSH. I'm SSHing into this. So in my project one, I'll go back to my virtual machine so that I can get server Taiwan IP address. So what we are going to try is something like this, folks. we totally have 3 virtual machines, right? We totally have 3 virtual machines. So server Taiwan in subnet Taiwan to server SG, which is in subnet SG. This combination we want to try. Then we want to try one more combination, which is this one. And we want to see another combination, which is this one, folks. Now, between server Taiwan and server SG, we saw it works. We saw it by ourselves, right? There's no doubt. Between server Taiwan and server SG2, the new subnetwork which we added is what we are going to just try now. So I'm already there. I'm in my server SG2. Let me just ping the IP address of server Taiwan. Copied. Ping. What do you think, folks? Is it going to work or not going to work? Just do a calculated guess and we'll find the explanation later. What's going to be your, based on your understanding so far, what can you say? Okay, I get one response, second response. Anybody else wants to give a try? Hit enter. Yes, Anil Kumar is correct. So it's not going to work. Simple. It's not going to work. Why? You don't have a route. You added a new network or a subnetwork, to be very specific in GCP. You added a new subnetwork. This information you have not even mentioned it, right? How will the other side know? Yes, there is a new network, a subnetwork added. I have to, that should be my destination. How will I send the packets? So it is not there. So we have not added a route itself. So it's not going to work. It's not going to work. So this will not work. Now coming to the last option. This is what we are trying. Server SG to server SG2. Will this work or not work, folks? Will it work or not work? From SG to SG2. Okay, one response. Kumar got it correctly so far. Only Kumar got it correctly so far. It's a binary answer, yes or no, that's it. Folks, it's always sticking on to the basics. So whatever the high concepts you learn, if you stick on to your basics, things are going to be very, very clear. So when two VMs needs to communicate each other, we need to find out whether they, what is the network, a subnetwork they belong to, what is the firewall rule. So we don't have a restriction at the firewall rule, which we have made it as pretty open. Now, both are in the same VPC, folks. So it should work. It should work. Only Kumar got it correctly. So it should work. So this is nothing but the same stuff which we learned in the first beginning of our networking class. So even though we have come to an advanced part, does not matter because we are in an advanced thing, the basics are lost. No. Same VPC, right? VPC Singapore. So from server SG2, it should work. Let me just verify it. So Taiwan is not working, but if I copy my SG1, sorry, SG, it will work. It will work. Hope it is clear, folks. It's the same network. You don't need a peering. Nothing required. It's going to work. It's okay. Is that clear? Okay. So basically, this also works. So the only thing which we need to make it work is the new network or the subnetwork which is added, make it work with the other side, the Taiwan side. That's going to make it a complete working set. How do we do it? It's just the most important thing which a network engineer may do. So in cloud, in GCP, even the cloud architect can have a role to play here. So there are different ways for this to make it work. One way, what I do is basically the route is not there. That's the simplest thing, as simple as that. There's no route from my Taiwan to my Singapore subnetwork 2. If I can create a route, everything is going to work. Now, how do I create a route? Different style. You can dismantle your tunnel, create a new tunnel, and update in the new tunnel, add both the cider ranges. So if I just go back, so I'm in project 1, so I have added only subnetwork SG. So you add one more route which is subnetwork SG2, then it's going to work. Basically both this network, you have subnetwork you have to add, so then it's going to work. So for doing that, maybe you have to dismantle the tunnel and create a new tunnel. That's one style. But the drawback of that option is there's going to be a disruption. So for a short time, the network, if there's any communication happening, it's going to be disrupted. So this is one way. If you want, you can try it. We wanted to try something which is little different, a little hacky, but cost effective. What we are going to do basically is we never created a route. Why don't we create a route? Basically, we know the destination IP. This is the destination IP, right? Copy it. We'll just basically go and add a route manually by ourselves and see whether the communication can be established or not. So that way we'll learn how to create a route also. Okay, now this is the right time for us to know how to create a route. So what I'll do is I'll come to project 1, because that's where the route needs to be created. Click on create route. I'm going to call this as manual route. The network is VPC Taiwan. From VPC Taiwan, the destination is going to be my subnetwork SG2. Priority, the same concept takes, lower value takes precedence. The highest priority is 0. Same like your firewall rule. But for us, 1000 is good enough. Then you can have the next hop. Multiple options are there. It could be a default gateway. It could be an instance. It could be an IP address, or it could be a VPN tunnel or a forwarding rule. We are going to use VPN tunnel, and we are going to use Taiwan. That's it. So if I click on command line, it is going to be the same command which you also saw in our VPN tunnel creation page. So routes create. It's the same thing. Now I'm not going to click on create. Before clicking on create, right, I wanted to show you this part. So I'll try to make it something like this. Something like this works. Okay, so this works because this is server SG, but this does not work because this is Taiwan machine. It does not work. Now what I'm going to do is I'm just going to click create here, which is going to create a route. The moment the route is created, you will really see the ping starts working, meaning a road is established. There's a connectivity built. So then the packets would be sent. Let's wait. You see that? The connectivity is set and you should see the ping start working. Beautiful, right? So now you see the real value of route. Is this part clear, folks? Is this part clear? Now we made everything work. Basically, the first and the last one worked automatically, but the middle one, you had to add a manual route. So which requires you to understand the network topology, where in which side you have to add a route, what should be your destination, all those things. more of your networking exposure is required. So with our knowledge which we gained, we were able to do that. Manual work, manual route needed. Is this part clear, folks? Is this part clear? But took us time for us to understand and then do it. And we also leveraged how the route works basically. So any questions on this before we dismantle this and go to the next part? No questions? Okay. So if things are all fine, so every time we need to create a route. Yes, if you are going to expand your one side, maybe on-prem or GCP, whatever it is, if you are using static routing, whenever you add a new sub network, you have to add a route in the other side. This is a manual task. Or if you want something better, you look for something called as dynamic routing, which is going to avoid this multiple time creation. It's one time activity. So this is the drawback of your static routing, Kumar. So every time you have to add it. So adding a route is one option. Another option is dismantle the tunnel, create a new tunnel with all the updated network. That's another option. And there's no standard procedure for updating your routes in a static routing. Everybody does it in different style based on their network exposure. But the easiest one, cost effective one, and also for us to leverage how to create a route, I took this option. So different people can do it in different style basically. Now you saw the real pain of a network expansion. What is the impact? You have to go do all these things. Now the better option is going to be using dynamic routing, which we are going to talk. Before we do that, I wanted to okay, let me explain it and then we'll do the demonstration. So solution which is going to overcome this part, adding it every time is going to be a pain. So the solution for that is called as dynamic routing. So the name itself indicates the routing is going to be dynamic, not static. It's going to update automatically. So before I explain this one, right, I guess most of us uh, have come across, you would have seen your child, you would have seen yourself. So at least I have done this when I was a child. So um, and it was a community in which I used to live. So it was not those days flats and all. It was a individual house. So and you used to have neighbors whom with you used to play. So assume you just a small out of thing, but the context is going to be here. So if a child gets a new pencil box, a new a cycle or a new ball or a bat, whatever it is, the child or the child, right, will go and say it to the neighbor. And in that neighbor house, if there's another child, that hey, I got a new box and you got a new pencil, a new eraser. Basically the child used to advertise. And if it was a slightly bigger one, say for example a bicycle or a cricket bat, and the entire community there, every child will come to know, okay, Mahesh got a cycle, a new cycle, a hero cycle. So that kind of an advertisement was happening. So now the entire gated community was aware that Mahesh has a cycle. So this was basically an advertisement, right? So this was done by the child. Basically the same concept is what is going to be used in your dynamic routing also. So if you can do some advertisement that I have added a new subnetwork, please make sure this has been advertised on the other side, then job done. So you'll never have this issue. So only thing is that you're not advertising, you're not going to know that. So how to do this advertisement is using a protocol called as Border Gateway Protocol, BGP. So with the help of that, you are going to do that. And the component which is going to do that, Border Gateway Protocol is a standard protocol, okay, for doing this kind of an advertisement. So the component which is going to do that for us in GCP is called as Cloud Router. So that is the reason why I have mentioned the title as dynamic routing using Cloud Router. So how does this work basically? Let's take the GCP side of it. So GCP, you have a couple of subnetworks. You're adding a new subnetwork. Now this has to be made advertised on the other side of the network, so that if there's any resource which wants to communicate, they can do it. So what does happen basically is you have a cloud router configured. So this router is slightly different from the traditional routers which you would have seen. So don't try to connect this with your home router. So it is nowhere. But if you had seen any data center, the routers which you would have heard is Cisco routers, Juniper routers. So the actual routers which is the backbone for most of the data centers. These are routers which can handle both control plane and the data plane. So they have two planes basically, control plane and the data plane. So when it comes to the cloud router which you see in GCP, this is totally software defined. So it's not a hardware device. So if you have seen a Juniper router or a Cisco router, you can touch, feel. It's an hardware basically. This cloud router, right? It has only control plane. Anything related to the data plane, it's not going to handle. It's only the control part. Okay, so that's the difference between your Juniper routers and your GCP's cloud router. So this cloud router, what it does is it behind the scene uses BGP, and the moment a new subnetwork is added, it gets that information and does an advertisement indicating a new network has been added or subnetwork is added. Make sure the routes are updated. It does that. So this does that automatically with the help of the BGP, and this is the tool which does that. So for that, you have some standards basically, usually called as BGP link local IP address. What is this? Basically simple. This link local IP address is always going to be with a specific range, 165.254.x.x. So that's the range which is going to be used. So it is reserved. This range is reserved for BGP. So your if you replicate this on your GCP to GCP communication with dynamic, this one, if I take this, take my drawing. Uh, if it is GCP to GCP, right? On the other side also, I will have a router. So something like this. I'll have one more CR for cloud router. I will have exact stuffs. So I'm going to have two cloud routers, gateway, and I'm going to establish the BGP session and do the communication. And the routes are going to be updated automatically. The whole concept is advertisement, folks. Uh, and it's going to be very quickly advertised basically. So that's how this entire stuff works, and basically this is going to remove the pain of new subnetworks are added and how it gets advertised. So it's going to totally remove the pain of your static routing, uh, and that's one of the main reasons why many organizations they go with dynamic routing. And the only component which is going to decide is basically your cloud router. So we'll also see the price of cloud router once we finish the demonstration. I'll show you how dynamic routing really rocks. Once it rocks, it's definitely going to rock. Then we'll see the price of cloud router. Okay, so that's the only deciding factor. Everything is the same. You have a gateway, you have a tunnel. Only component is a router. Maybe 5 or 10 minutes more to configure it. That's it. So that's the only difference. So is it? So we'll just set up this, and we are going to do slightly a smart way of doing this demonstration. So what we will do, we will not dismantle everything which we have created. We are going to only delete the tunnels, because tunnel is the one which is going to decide what kind of routing, whether it's going to be static routing or dynamic routing or policy based routing. So gateway, we are going to keep it as is. Gateway, we are going to keep it as is. So what I'm going to do is little smart way of doing it. So I'm going to just close the stuffs. So what I'm going to do first, whatever I added manually, I'm going to remove it. I'm not able to delete this route. 1 minute. Okay, route deleted because that was added manually by you. I don't want that. Okay, that's deleted. Now this side, I have a VM. I'm going to delete this VM. I don't want this VM. Bringing it back to the beginning stage. And we'll do the same thing again one more time. So I'll delete the VM, delete the subnetwork. See, first of all, with dynamic BGP is going to have the connection established, and I'll create a new subnetwork, new VM, and see whether it's going to work. So that's what I am going to trying to do now. So VM deleted, and I will delete the subnetwork also. Back to square one. Let's wait for this. Done. Now what I'm going to do is I'm going to play little smart. I'm not going to dismantle everything. I'll go to my project 2. I'm going to keep my gateway as is. Gateway as is, which is currently the tunnel is only going to be deleted because the tunnel is the one which is going to decide what kind of routing type you are going to do. Route based, which is equivalent to your static routing, or dynamic. So gateway has no connection to what kind of routing you are going to do. So why do I need to delete it? I'm not going to delete it. I'm just going to delete my tunnel. So delete the tunnel. Similarly, on the other side, I'll also delete it. So project 1, I'll go to my tunnel, delete my tunnel, which is Taiwan tunnel. So I'm just going to delete it. So let's just wait for it to finish it off. I'll see the other stuff and see whether it is deleted. Okay, there's no tunnel in project 2. Only gateway is what I have. Similarly, there's no tunnel in project 1 also. Only gateway is there. So meaning we come back to the beginning stage where we started. So now the connection will not work. We have broken it, right? So it's not going to work. It's not going to work. Now we are going to fix this first of all using dynamic BGP. Afterwards, we'll come to the subnetwork expansion. So if a new subnetwork is added, how the advertisement is going to happen. So now only create tunnels on both the sides. Before we create tunnels, we have to make sure the cloud router is created because that is the additional component which you need to have. So cloud router is again a regional resource. It's a regional resource. So first let's create a cloud router in both the sites. So where can I see cloud router? Basically under your hybrid connectivity itself, you'll see cloud router. Click on create. Cloud router enables dynamic routes updates between your compute VPN and the non-Google network. Cloud router eliminates the need to configure static routes and automatically discovers the network topology. One single line explains the entire concept. Really good. Create a router. Give a name to your router. I'll call it as Taiwan CR. CR for cloud router. The network VPC Taiwan. The region, basically cloud router is a regional resource, which it is very clear from here. So Taiwan. And the last important thing is something like this is a router, right? So we are getting more into the networking piece of it. So when it comes to a router, there should be an identification number. uh, so how the package needs to be transferred. So every routers on the internet will have a ASN number, autonomous system number. So this is the one which is going to be used to communicate. So when it comes to Google, right, you are going to have private ASN numbers, and these private ASN numbers are going to be in these ranges. So between 64512 till 65534, and a huge range, this one. Either in these range you have to use it when you're using cloud router. So I'm not going to do much different here. I'm just going to copy the first one. Copy it and put this as my Google ASN number, autonomous system number. This is basically the identity or the identification number of your router. That's it. So now what kind of stuff this router should do? We know router basically does advertisement, right? So what kinds of routes it should route? If you mentioned advertise all the subnetwork visible to the cloud router. What is a subnetwork? How do it know? If you go up, you know you are mentioning a router for a specific VPC. Inside this VPC, what and all the subnetworks available, it's going to advertise it. Meaning, if I go to my VPC, if I go to my VPC Taiwan, how many subnetworks I see? I see only one subnetwork. So, and tomorrow if you add new subnetwork, it's going to also advertise that. So basically, it's going to, by default, we are giving it as advertise all the subnetworks which is visible to you. So that's a default one. Or if you want specifically, you can create it. You can create it. We are going to leave it with default one. Default one. So let's see the command line equivalent of this. Routers create. It's not route, folks. It's routers. So routers create the details. That's it. Now this information may be used later. The Taiwan routers ASN number. I'm just going to make a note of this in my cheat sheet. So okay, this is the one. Taiwan router. It's already there. So it's already there. So maybe I can just one more time paste it. Good. I have the router created because we are using both the sides GCP. So on the other side also we should have a cloud router. So, but if it is on-prem, you may not need it, folks. If it's on-prem, you don't need it. You need to just have the normal router, Juniper or Cisco routers. So router in project 1 created. Let me go to project 2. I'll go to my router. I'll call this as Singapore router, Singapore CR. Singapore CR, network, VPC Singapore, the region where you need to create your router, Singapore. And I'm going to play a little smart here. I'm not going to juggle around with the numbers, ASN numbers. So I'm going to do basically copy this +1. I'm going to do simple. I'm not going to do something too much complex. And these are something which we are looking at the first time, right? So let's not make it too much complicated. Using the tooltip +1, because 12 ending with 64512 is for Taiwan, 13 is for Singapore. Simple, not much complications. So I don't have that info. Yeah, here it is there. I have mentioned it. That's it, folks. Now let me click create. By the time this gets created, I'll go back to my cheat sheet and add this information. Cloud router. Cloud router. I have to freeze this column. Freeze. First. Okay. Cloud router is always regional resource. Done. Let's see. Yes, the routers are created, meaning as per the diagram, we have the routers ready. So it's only that setting up that tunnel specifically using dynamic BGP, we should be all good. So let's go ahead and do this. So I'll do it from my project 1 first. Project 1 has only a gateway. If I click on gateway, there's only gateway, there's no tunnel. So if you want to create a new tunnel, just click on add tunnel using this gateway. It's going to give a name, very nice, VPN Taiwan Gateway -tunnel 1. Now the same stuff. What's the peer? So we already know that this is our Singapore's static IP address. Copy it. Done. IKV version. Now for a change, I'm going to use a simple text, folks. So we know a complex text can be also used. For now, I'm just going to use this. Just wanted to show you all the variations. Done. Now the most important thing is, last time you use route based. You used route based. Now if it was static, right, new networks added, you keep on adding it and it's going to start working. But you have to dismantle your tunnel and then only you have to do it. But we took a smart way. We just manually added a route. It started working. So we understood totally the drawback of static routing or route based routing option. Now we will use dynamic routing, BGP. So basically, when you see BGP, the first and the foremost thing, the requirement is you need to have a router. And that's the reason we created the router. You can create it by just clicking on create here also, but I wanted to create well in advance. A little systematic way to do that. That's it. Cloud router mention. Good. Then the next part which you need to have is a session needs to be established. A border gateway session, BGP session needs to be configured. How do I do it? Just click on this pencil icon and it's very, very simple. So give a name, and giving a good name is going to help you out basically. So I'm going to call this as BGP Taiwan SG. That way I understand this is from Taiwan to SG. So what is the peer ASN number, folks? If you just mouse over on it, the ASN of your on-premise side of your BGP session, the ASN can be a public or private. So in our case, what is this going to be, folks? The peer ASN, what is this going to be in our case? So if it's on-prem to GCP, it's going to be your on-prem. So in this case, it's going to be our Singapore's cloud routers ASN number. So if you don't remember it, your cheat sheet is going to help you out. This is our ASN number. Done. That's a mandatory field. And there's an optional field which I'm not going to touch upon. So it's optional. So let's not even break our heads with those things. Mandatory thing is basically your peer ASN number. Then is your cloud router config, the BGP IP. So the BGP IP, the link local IP, which I mentioned. So if I just mouse over on it, Google BGP and the peer BGP must be a link local in the same /30 subnet. Make sure that they are not the network or the broadcast address of your subnet. So that's the information. So 169, I'm just going to use what is mentioned here. I don't want to do too much extra work. I'm doing this for the first time. This is my Taiwan's BGP IP. My Singapore +1, folks. Simple. +1. That's it. So my BGP session is configured. So just gave my peer ASN, my BGP IP. And similarly, when I do it in Singapore, I'm going to do the reverse of it. And similarly, you have the advertised routes. How you want to do? Again here. Default is whatever the router finds it, you advertise it, or you want to have a specific thing, you can do it. For us, let's go with the default option. So click on save and click on create. Before clicking on create, just wanted to show what we did once again. So we gave a name. The name was automatically created because we clicked on add a tunnel. We gave the Singapore static IP address, the gateway. Use a very small password, secret, not highly recommended. Just wanted to show the different flavors there. Used dynamic BGP where a router was configured and the BGP session was configured. It was very simple. The key part was the ASN number and the link local IP address. That's it. So let me just go ahead and click on create. So, and a small tip, folks, when you click on this, right, the notification is going to go. Please don't click on the back button. If you click on the back button, it may go to the edit mode again. Okay, so don't do that. So let's wait for the session to be configured. First of all, session to be configured. I'm going to do the same thing in my other side also, in my other side. So let me just wait for this to show up. Or the better way to see whether the tunnel is created or not, go back to the home page of your hybrid connectivity, go and check your the same, but don't click on the back button. Okay, don't click on the back button. Now my tunnel is created. You see the routing type. Previously it was routing based. Now it is BGP or dynamic routing. Tunnel status, no handshake happened. BGP session waiting for the peer. So we are waiting for the Singapore side to be done. Once it is done, we should have the connectivity. Let me see whether the ping is working. Not working. So we have to finish the other side of it. So let's do that. I'll go to my project 2 and configure a tunnel. So you can create the tunnel here also, or you can click it from here. If you click from here, basically it's going to give a name automatically. Most of the details are getting populated. It gets populated. Otherwise, if you click on directly create tunnel, it's going to ask to which gateway. Let me know the sorry. If you click on tunnel, if you click on create a tunnel, first it's going to ask for which gateway you want me to create a tunnel. The gateway is very important. So you have to select your gateway and do it. Two different ways, styles of navigating, folks. That's it. So click on continue, then it's going to show the same screen. Instead of doing 2 clicks, you do only 1 click. Smart way. That too when you're doing in any demonstration. So the remote is going to be a Taiwan's static IP. Copy it. IKV version 2. What's the shared key? Batch 6. Little easy to remember. BGP session. The router, we have already configured it. Configure your BGP session. Now I'll call this as BGP SG to Taiwan. SG to Taiwan. Now the peer ASN. This is going to be your Taiwan's. This is going to be your Taiwan's. So if you don't remember it, you can see the cheat sheet. Done. Now the most important part is the BGP peer IPs. And so 69.254.0.2. This was my Singapore's, and my Taiwan's is this one. Done, folks. That's it. I'm just going to click on save and continue and click create, jump back to the terminal. So let's just wait. It's going to create the tunnel. The BGP session is going to be established. Handshake is going to happen and the session is going to be established. Once everything is done, it's going to work. If we have not done anything mistake, anything wrong, it should work. If we have done many mistake, we'll definitely fix it. So let's wait for a minute here. Yes, one gateway is enough. One gateway is enough. Okay, it's working, but this time you'll not be so thrilled. I know, because you're seeing it multiple times. So it's going to work. So you're not so excited. I also know this. So I'm just going to stop this. So meaning you have brought it back to the same stage what was there. So you removed your static routing, you added dynamic BGP, everything is working fine. So far so good, but you are still not impressed is what I would say, because we have done this multiple times, we know how it works. But the beauty of dynamic BGP is when you add a new subnetwork, how the advertisement happens is what I wanted to show you, which is going to really make you excited. One time setup, that's it. What you have done, that's the setup. Now you have set it up, just go add new sub networks. It's going to automatically advertise it. So let me just show you that. So what I'm going to do is repeat the same thing. In Singapore, I'm going to add a new subnetwork and we'll see whether it's going to reflect or not. So for that, I wanted to show you in my project one routes. If I put a filter, I see basically the dynamic route added. And you can see either in all or you can click on dynamic. You can click on dynamic also, it's going to show you this. It is going to show you this. And it also says learned time. This is an important flag actually. When it learned it, when it got that, oh, there's a new route added. I learned it this time, basically. So hope my time is correct. Yeah, my time is in Indian time zone. So it's going to show it learned at this time. Good. Similarly, now when I add a new subnetwork in Singapore, the route should be learned in my project 2, which is my Taiwan. Let's go ahead and see what's going to happen now. I'm going to go to my project 2, do the same stuff, copy this IP, create a new subnetwork called as subnet SG2. Same region, I make it as 4. That's it, folks. That's it. The moment I click on add, what's going to happen is the route, it's going to advertise. It's going to learn, okay, a new thing has been added. So if I see it has been added at 8 roughly. Now if I go to my project 1 and refresh it, not there, not there. Still not reflecting. Okay. 8849. Yeah, 8849. So it took around 40 seconds roughly. So for it to learn the new route, meaning the one which you did manually is now done automatically, dynamic. So this is the key part. Now since a route exists, I can 100% sure if I create a VM using subnetwork SG2, it's going to definitely work. But let's not just leave it as is. Let's do a demonstration and understand it correctly whether it's really going to work. So I just added a subnetwork. Previously with static routing, this kind of routes were not added. So to fix it, we created it manually. Now with dynamic routing, it's automatically created. So the major work is already done. So I just need to go create a virtual machine. So I'm going to use a better way. I'm going to click on create a similar virtual machine. Create a virtual machine SG2. Are you a troublemaker? Is it going to still troublemaker? Let's see it. So Singapore, everything is going to be good. I'm just going to change my network. Change my network to SG2. Done. Click. Now from this server, I'm going to ping my Taiwan machine and see whether it's going to work or not. My hunch says it should work because the route is there. Route is there. And we already know basically VPCs, these are in the same VPC, it should work. This one and this one should work. So basically now I'll SSH into this. So I'm in my troublemaker machine. Let's see whether it's going to be really a troublemaker or not. So I'm in my, I'm just going to copy the Taiwan machine's IP. Taiwan machines IP, hit enter. Works like a charm. So no issues because the route is there. Now you want to add more, it's going to work. Let me just stop here. Now you may really appreciate dynamic routing. Let me just stop here for any questions, folks. Any questions on this part? So how the advertisement happens, everything is seamless. Now it may come to a point, is cloud router so expensive that I cannot use it every time? Or what is the cost? Is something which will come to your mind. I'll answer that in a minute. But before that, any questions so far? Any questions so far, folks, on this dynamic routing?
Manish, I have posted one question. Matlab means one.
You need one tunnel, one gateway. I told yes. One tunnel,
Okay,
one gateway is enough. One gateway is enough.
at least it supports four. It supports four tunnels. So we can create up to four tunnels with a single gateway.
Okay, you have seen it already. So if you have seen it, you can mention the answer also, Vivek. No need to test my understanding
No,
there.
no, no,
So
I'm
if
just
you already
checking.
know it, you just met it.
No, I'm just checking. Actually, I
Okay.
saw that we can create four tunnel. Means there was
Mhm.
a considering HA actually
So
HA.
here, if you come to your,
I'm very new with networking and all that, right? So
so
if
if
you
you
create,
just click on 1 minute, if you click on this one, right? If you are going with HA, so here, so you see basically two interfaces you are creating, two network gateway interfaces. So you're going to have totally four. If you're doing HA, we have not done HA. We have not done HA. So just give me a minute.
even I just heard you can create up to four tunnels. I think that is in only in HA, but I never tested. I never seen. Just asking for my knowledge whether
Okay.
we how
Okay.
much
So
extent.
okay. The thing is that HA VPN, right? Uh, in HA VPN, you are going to have two tunnels. So basically, in HA VPN, how it works is basically they call something called as network interface. So you are going to have two gateways in one network. So you're going to have totally four. You're going to have totally four. So if you're using classic, one gateway is enough. One gateway is enough on both the sides. So if you're going to use HA, it's going to be two, because you're going to have multiple tunnels, right? So you're going to have two here, and you're going to do it. So that's how it basically works. So
Oh,
that's how it basically works.
okay. One thing, just keep, tunnel can support up to 12 Gbps. Means what does it mean? Uh, eh, how we can get 12 Gbps of throughput maximum, which I read in the.
That's a question which I asked for you. Explore it. Next week you can say, if you have not explored it, I can say the answer. Anil Kumar already mentioned it. So how can you have 12 Gbps is what they mentioned in the documentation
Yes,
for
which I read.
HA or for classic?
No, I
For
didn't
classic,
remember.
it's going to be maximum 3 Gbps classic. One tunnel is only 3 Gbps per my understanding. If you add two tunnels, it's going to be six. It's going to be six. Or if it's active kind of a stuff, or if it's only for redundant purpose, it's going to be still again 3 Gbps. I need to see whether it is 12, they have changed it or not. But if you want to use the complete want to have that throughput, there's some setting which you have to do basically in your virtual machine. I would strongly suggest you to explore that. If you're not able to get it, next week I'll share you that information. There's some settings. So this is something to our learnings only, what we learned already. So just checking your stuff. So whether you are able to connect your virtual machine details with your networking stuffs. Okay. So any other questions, folks? Any other questions, Vivek, you have?
No, no, that's it. Thank you.
Yeah. Any other questions, folks? I'll come to the price of router. soon. Anything else? Cloud router. Can you show the ASN? Yes. So ASN, cloud router. So you want to create a new ASN, this thing, or you want to see the number? What is that, Kumar? You want to do the values? If you want to see new ASN, you can create new ASN as long as it's not conflicting. You can create it. So the range is that you can create new ASN. So for new cloud router, you create a new ASN. So for us, one cloud router is good enough. One cloud router is good enough. You can create as many routers you want. Usually, that's going to be the next part which I'll come. For example, throughout this demonstration, if you see, I was doing a little trick. What was that trick? I was always trying to create a subnetwork in the same region, folks. Same region, if you remember. That was the trick which I was doing. So to avoid having multiple routers, Now, to answer Kumar's question, if you create a subnetwork in Hong Kong or maybe some other region, then you need to have basically another router. Then you have to do it. So n number of routers you may need to add. And this is how you do it in other cloud also. So new region, you add new cloud router. It's very standard one. But when it comes to GCP, right? GCP's network is global. So what you can do is you have a new option or a slightly unique option which you don't get it in other cloud. You don't need to have multiple cloud routers or equivalent of it. So using something called as routing mode, global routing mode. You see this one? The VPC currently is going to support only regional one. That's what you have configured as. So meaning within the region, if you add n number of subnetworks, it's going to route it easily. So meaning if I add one more SG3 in Singapore, it's going to automatically show, it's automatically going to basically, where's my route? It's going to basically add a new route. We know that. But let's give a try. The trick which I was playing, let's break that. Let's add a subnet, but not in Singapore. Let's add it in Hong Kong. Which in GCP, you don't need to have multiple cloud routers. In other cloud, you may have to have multiple equivalent of cloud routers if you are going to do something like this. So Hong Kong should be East 2. So I'm going to mention basically +1. Done. It's added at 819 currently. Let's see whether our cloud router is going to learn this new information or not. Added completely, not yet. Okay, added completely at 820, 16 or so. Now, if I go back to my routes, refresh it, or forcefully refresh the browser, wait for minutes, as it's not going to show you. Why? Basically, the VPC which you are going to use, if someone uses the same IP range, then how it will handle? Same IP range, Okay, here it's going to have a conflict. So it's going to have a conflict. So if you try to add something, it's going to have a conflict. Maybe I can show you that once I finish this part of the demo. So I've added it. It's added. I've added it. It's now almost 21. If I refresh it, go to my dynamic, it's not going to show that details. The reason is your VPC, when you were creating the VPC, you mentioned the dynamic routing mode is going to be regional, meaning anything in the region, I'm going to advertise it for you. Whatever happens within the region, I'm going to advertise it. But if it's outside of my region, I cannot do that. Basically, is what it indicates. Now, if you want to make this routing mode global, which is again unique in GCP only, what you can do basically is, if you click on edit, before I click on edit, I go back to my VPC creation. So we have seen subnet, mode, auto, blah, blah, blah. Private Google access we have seen. Flow logs, we'll see it soon once we look into the log details. Last option, dynamic routing mode. So we did not explore it. Remember, I told we'll just leave it as default. Why? Because we were not knowing what was dynamic routing mode itself at that time. Now we know what is dynamic routing mode. So it shows global dynamic routing allows all the subnetworks regardless of the region to be advertised to your on-premise router and region when using cloud router. Meaning, to handle what Kumar was asking, can we create a new ASN? When do we create a new ASN? For a new cloud router. Why do you need a new cloud router? When you have a different region. This is going to be done in other cloud like this. But in GCP, you don't need to have another cloud router. You can have only one cloud router. And your VPC, you can make sure it is going to have global routing. So global routing lets you learn dynamically to and from all the regions with a single VPN or a interconnect and router. With one single router, it's going to be done, job done. So this is the part. So by default, it's going to be always regional. If you want it to make it global, it is possible. You can change it anytime. Let me just do this in my existing VPC. Currently, it shows as regional. Before I make it global, let me just go back to the project one, refresh it and show you whether the route has been added or not. Route has been added or not. Go back to my dynamic. It's not added. It's not added. So it's more than 3 minutes. It's not added. It's not going to add because it's a different subnetwork. So, and the routing is only currently regional. So to make it global, simply edit your project 2. In your project 2 VPC Singapore, edit the routing mode to global. That's it. Make it global. Save it. The moment I save it, done. The moment I save it, come refresh. In next few minutes, you should see it, or few seconds. It's not reflecting. It should reflect soon. It's global, right? So it's going to get those details. It's going to take time. Added. You see this? It's added, and the priority is going to be slightly different. So basically, the route has been learned. So this is nothing but my Hong Kong. Now, meaning if I create a VM in Hong Kong and ping my Taiwan machine, or from Taiwan to Hong Kong, I should be able to do it. Let's just do this part. Then I'll come to Mangesh's question about adding a conflicting IP, same IP. What is going to happen? That's a question which I never got it, but let's give a try. So let's give a try how it happens. So I'm going to create a similar machine, Hong Kong, HK, uh, mm, Hong Kong, uh, HK automatically comes up. Click create. Will HK and SG interact each other, folks? It's going to interact because same VPC, same VPC. Yes, it's going to work. So I'm not going to do that ping, or if you want, I'll ping it also and show you. The most important thing is ping your Taiwan machine and see. So first I'll show the Taiwan machine and then I'll come to my SG machine. So Taiwan machine also should be possible because the route is already there. As long as the route is there, I should be able to do it. So I'm in server as Hong Kong, ping it, works. Similarly, if I copy the Singapore machine, why the clipboard is not okay? Singapore machine, it works. It works basically. So ASN is nothing but Mangesh, it's nothing but your identity to your router, an identification number to your router. And this is the one which is going to be used for your BGP session. Basically, in one line, if I were to say, that's the identity, and it has to be unique. That's the identity of your router, cloud router in GCP. And this is basically a private ASN number. And if you look, say for example, look into the internet, there are lots of routers which act as the backbone of the internet. They will have a public ASN number. They will have a public ASN number. For example, if I just go to IP uh, uh, IP finder, lookup, yeah, IP lookup, sorry, IP lookup. So if I put what is my IP, IP5, this is my IP address. If I copy this IP address and put it in this lookup, I'll come to know the ASN used by, so I use ACT as my this thing. So this is the public ASN of my ACT of my broadband. So this is public ASN. So every routers are going to, and this is not my home routers ASN. Please don't remember confuse with that. This is my cloud provider, sorry, my ISP provider's ASN number. ACT is the one. Okay. So what you used is basically is a private ASN number. Private ASN number. So now to one more question. Never tried it. Let's give a try. So peering is established. Routes, everything is going to be good. Now, what will happen if you add? So for example, so let's make this little clear. Subnet Taiwan. This is the this thing which you have. Similarly, you have subnet SG. Let me copy. This is the one. Then you have subnet SG2. Subnet Hong Kong, which is going to be something like this. So is your question, Mangesh, something like, what if I add something like this on the other network? Is your question? Without knowing, I mistakenly added it. Okay, let's give a try. Should definitely show there's a conflict. So let me copy SG2 and add this in the other side. Okay, so I'll call this something like Mumbai, but the IP is going to be same. So or let me put it in Taiwan itself for now. Let me put it in Taiwan for now, or I'll do this one. I'll copy this. I'll go to this network. I'll create in Mumbai, subnet Mumbai. It should show me that error. Mumbai is this one, but I'm using the same CIDR which is used by Taiwan, subnet Taiwan in the other project. Now we should have some issue. Let's see what happens. Never tried it, but based on the understanding, I feel it should definitely have some conflict, should give some logs or something. Created. Now let me see in the routes what's going to happen. It does not throw any error. Not sure whether I can reach. Let me create a VM. I will remove this one, this one. Let me create a VM in Mumbai using that and see what's going to happen. Nothing in this thing. Nowhere it did not throw any error. So let me create one more in Mumbai. Create a similar one. Hope in Mumbai I can provision it. C should work is my understanding. Let me see the network. It should be set to Mumbai subnetwork. Good. Now let me create it. Somewhere there should come up some error is my understanding. Because there's a conflict already. These are connected. We can also see by the time this comes up, okay, it already showed an error, maybe not this one. So it is not because of the network, the resource is not available. This is the reason why I avoid Mumbai. There's some issue, not enough resource. Let me try to do it in A zone, folks. I have to always find which zone is available in Mumbai. So that's the reason I started avoiding it. Some issue from last April. If I go to Mumbai, select A zone. Okay, it is provisioned. Okay, in Mumbai, I am able to provision it. Now, mm, 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 the only conflict which I see, let me see, is there anywhere, somewhere in the BGP, anywhere it is showing it's going to have issues. VPN. Is there a log which I can see, say, where at least it shows there's a conflict or something? View logs, gateway. We kept logs, not basically because we did not see much log information or stack driver logging yet. So that's the reason I have avoided logs as much as possible, like VPC flow logs, firewall logs. We have not even seen that. So, but here I would have expected at least it should have shown me a message. There's a conflict. There's a conflict. Mm, it's not showing that. Mm, I'll check this, Mangesh. So it's okay. If we can do some ping, we can do it. Let's just do a ping once. Now, if I SSH into my server, let me close all the other stuffs. So I'm in server SG. Now the most important part, which is going to be interesting, is if I from server SG, if I do okay. Let me just do this, folks. Let me just try this. Interesting question. Things which you get in the documentation is always good. We can also search it. These things definitely are going to be interesting. So if I ping from server SG, if I do this, let me see whether it works. Now you have broken the system, basically. Previously, it was working, if you remember, right? From server SG, if I ping my Taiwan machine, it was working. Now it is broken because of that conflict at the IP. So it did not show anything, but it has silently stopped working. So, but if I ping, the only reason is because you had the same subnetwork. So now you cannot reach Taiwan machine basically, only because you added a conflicting IP. But it could have shown it. Maybe we have to look in the logs is what I see. But what we have done is we have broken the system. We have broken the system, Mangesh. So by adding a conflicting IP, the other side of the network, I'm not able to reach it. Okay. So let's see whether if we delete this network, will it restore back? I never tried it. So let me try deleting this VM and the network. Will it restore back? Will it restore back? But it did not show any error. Maybe I have to see it in the log. I'm not sure. I'll see it. But what we can see quickly is we have broken the system by having a conflicting IP. Something like what we saw in our VPC network peering, such kind of an error would have been a better, saying that there's a conflicting overlap. That could have been a better one, but here it was slightly difficult. Now, somebody, if you want to, you can use this as, this could be a bad guy who's trying to do this, right? Uh, uh, who wants to break the system, you have a conflicting IP, then the entire connectivity is going to be lost. Can be done. Let's wait for this to get deleted. For the last 1 week, I'm seeing the VM deletion is taking longer time. Too much load. I'm not sure what is the thing. 90 seconds, it should be usually deleted, less than 90 seconds, but it's taking longer time these days. We'll just do this part and then take a break, folks. And once you come back, I will show you how to dismantle the entire stuff, because I would strongly suggest you to do this demo yourself. Uh, and how do you dismantle it is an important stuff. I wanted to show you that. Why it's not deleting? Oh, creation also is creating a longer time. Deletion is also creating a longer time. Okay, VM deleted. Now I'll delete the subnetwork. Before I delete the subnetwork, I wanted to show you whether I can still reach Mumbai. I cannot reach my Taiwan machine. I cannot reach my Taiwan machine. What I will do is do something like this. So on my left hand side, I have trying to connect to Taiwan ping. It's not working. It was only because of this troublemaking subnetwork. Let me try to remove this. How do I remove it? Yeah, remove it. If I delete it, let me see whether at least it can restore it. My understanding is should work after deleting it. Let's see it. Will it work? Let's see it. Awesome. So now it should be very clear, folks, right? So if you have a conflicting IP, you're going to break the tunnel, basically. Avoid it because it's not very intuitive. I will also see the logs, whether we can see that log. But allowing it should not allow to create itself is what I would say, basically. But it allows you to create it. So after you do it, you see it is back. It is restored back. So we'll stop it here. Take a 10 minutes break. Once we come back, what we'll do is I'll show you how do we dismantle this setup. I want your thoughts also when we are dismantling it. Usually the dismantling is always in a reverse way. It's always in a reverse way. Maybe why don't we dismantle folks first, then take a break so that we will have a flow. And when we come back from break, it's going to be a new topic which we are going to learn. So uh, how do you dismantle it is usually the reverse way how you do it. If you are using some tools, that's always a good one, which we are going to learn slowly in our module 7, where we are going to talk about some deployment manager, a little bit about Terraform at a very, very high level. When you dismantle something, right, do it in the reverse way. So meaning first delete your tunnel, then gateway, then your cloud router. Okay, cloud router, we'll come to that, should we delete it or not later. Cloud router, all those things you delete it. Later, anything else, what was first created will be the last one which gets deleted. Basically, that is the rule. So let me just go ahead, dismantle it. So if I can dismantle my routers first. Oh, okay. I cannot delete the router if it's been used by in a tunnel. So I have to first delete the tunnel. I was not knowing that. So delete my tunnel. Delete my tunnel. Same way, I will delete the tunnel in the other side. First, always tunnel. Tunnel is deleted. Then delete my gateway. Because the tunnel is deleted, I can delete my router. I can delete my router. The dismantling process is also important. First, let me delete my router in my project 2. What else? Gateway. If you do it via Terraform or deployment manager, which we have not even seen, the dismantling is going to be one single command, folks. So easy. But since we are doing it via UI, we have to do it like this. So all done. I guess I'm done. I'm done. If I go back, anything else which you feel needs to be done, folks? Tunnel, gateway, what else? VMs, VPC is not going to cost. Routes automatically gets deleted. That was a beautiful question. This thing, the routes gets automatically removed. So if I go to my routes, dynamic routes, it's going to be removed automatically. Same is the case in the other project also. So if I get to my routes, no dynamic routes. These are all the default routes, no dynamic routes. Anything else, folks? Anything else which needs to be removed? Or we are all good? We can go for a break. Anything else which needs to be removed? Beautiful. That's good, Anil Kumar. So anybody else wants to find it out, folks? Something which is very important is missed. We are not still dismantled it. Anything else which is missed here, folks? Router deleted. We deleted route out. We deleted it. And even if you don't delete also router, it's okay. I'll show you that in the next after we. Yes, Mangesh, that's correct. So basically, Anil Kumar and Mangesh got it correctly. Anybody else wants to try it, folks? Before I go and show you what is that which is very important, which we have missed still now, which we have not done, which is going to be a little expensive if you forget it. BGP session is already deleted. When you delete the tunnel, the session gets automatically deleted because the session is attached to that tunnel, and tunnels are really expensive. We deleted it. So simple, folks. What you see here. So tunnel deleted, gateway deleted, VPC don't need to delete it. External IP address is not deleted. You have not released it basically. So meaning if you don't release it, as Mangesh and Anil Kumar mentioned, you will be charged heavily, folks, at an hourly rate. At an hourly rate, it's going to be charged. You see, it's back to none. So please, when you do it yourself, please make sure you release it. Otherwise, there's going to be a huge cost, roughly around $7 US dollars. It's going to be charged monthly, and you'll not even notice that. So make sure you release it. It's an important one. The whole reason why I wanted to show the dismantling was only to this one. Release this. Then I would say you are complete. You're complete with all the stuffs here. You're completed. So this is something which I wanted to talk. Now we'll take a break. Once we come back, the one which did a game changer was our cloud router. We're going to talk more about cloud router, the pricing of cloud router, all those things once we come back from the break. Okay, so take a 10 minutes break. And
This conference will now be recorded.
all right, folks, before the break, we explored more about the dynamic routing option, which was used heavily by, or the one which was helping us to do that was cloud router, which behind the scene uses BGP is what we saw. Now, one important thing which I observed was basically the question which Mangesh asked: if we add a duplicate or a overlapping IP, what's going to happen? We saw it's going to break it. I was just thinking during the break time, just thought. I did not look into any documentation. I need to look into it. What I think is there's going to be something called as local routes, which is to your VPC, right? And something which is routes which is learned, dynamic routes, dynamic routes. Both are going to be there. And now if you see, if you go back, look into the recording once, the dynamic routes which was created, right, basically we're having priorities like 100, 336. These were the priorities which it had. But the local routes which you create, for example, if I go to project 2, routes, look at the local routes, folks. You cannot override it. 0, highest, that's the highest one. So the local routes always takes precedence because their priority is 0, which is the highest one, which you cannot override at any cost. So that was the stuff which worked behind the scene, is what I feel. Local routes always takes precedence over the dynamic route which has been learned. Okay, so that could be the proper explanation, is what I feel. uh, Explore it. So priority was the one which was matching, basically. Maybe if you want to try it yourself once, okay, this one I cannot even delete it. I guess there's no option for me to do anything which has to take the precedence as the dynamic route. The local route always takes precedence, basically. I'll also see some documentation. Is there anywhere we can get any notification saying that there's a duplicate or an overlapping IP added? I'll check it. Okay, so now let's go back. So the major component, as I mentioned, was cloud router. So now you have a thought, should I go between static and dynamic? The only component which is different is cloud router. So what could be the price of cloud router is going to decide whether I will stick on to dynamic routing or to static routing. That's going to be the deciding factor normally, right? So that's the only that's the only component which is different. So if you just look into your documentation quickly, search for GCP cloud router price, you'll be really happy to see it. Official documentation, cloud router is free of cost. Cloud router is free of cost is what it indicates, and there's going to be a very nominal cost which is very, very negligible for the BGP traffic. So it's totally free of cost, meaning you can also leave the cloud router running. It's not going to cost you anything, basically. So which is really the hurdle which was there is broken now. Now, what would be your take, folks? Which one would you prefer always? Dynamic routing or BGP routing? Sorry, dynamic routing or static routing? Which one would you prefer now? The cost constraint is also removed. Basically, uh, everybody is going to prefer to use dynamic routing. Simple. So they are going to use dynamic routing. Only thing is that it's going to have some more additional configuration, but this is a one-time activity. So I would prefer to do always dynamic routing. Now you come back to the first time when we did our cloud VPN demo. When we did our cloud VPN demo, we saw high availability VPN, right? So you see that high availability VPN, we did not do a demo on that. It's going to be on the similar lines. If you see, classic one supports dynamic and static. I wanted you to understand static routing, then you can really appreciate dynamic routing. Now, if I directly had gone with HA, you would have only learned dynamic routing. So maybe for production grade, the preferred option is always high availability VPN. The SLA is better. Then also, you also prefer to use dynamic routing there. So they are not even having static routing. This is the main reason. You don't need to pay anything extra. So, but you have to pay for the VPC and the public IP. That is going to be always standard. Though the component which is important here is only the component which is different is Anil. So is a router. That's the only additional component you added, nothing else, right? So it should be VPN is going to be always. So if you need a VPN tunnel, the VPN gateway, the tunnel, everything is going to charge you. I'm just comparing static routing and dynamic routing. In static routing also you had tunnel. In the dynamic routing also you are having tunnel. In static routing also you have a gateway. Even in dynamic you have. The only new component which was introduced in dynamic routing was the router, which is totally free of cost. With that being the case, I would always prefer to use dynamic routing. Only if it's a short proof, a small proof of concept, not much to play around. Quickly, if I want, I will just do static routing. Or maybe I can treat static routing is only for learning purpose, for you to understand better how routes work. You can use it for that. That's my understanding, folks. Now let's just do a small comparison between both the stuffs. Uh, Dynamic routing is best suited for organizations which is very dynamic in nature, where their network topology keeps on changing every week, every day, or every month. Static routing is suitable for organizations which is their network topology is very stable. They don't even change it for months or for years. So very short, very simple, easy to implement. They can prefer static routing basically. And when you want to create, update, all those things, you have to do it manually. New routes, all those things, it has to be done manually. But here it's totally going to be automatically created because of BGP used. If you were to basically add a new route, something like the one which we did, there are different methodologies. People use different methods. There's no standard methodology. Different vendors, different people with their different network skills, they use different approach. But when it comes to dynamic routing, there's a well-defined option. Just use border gateway protocol. Use a router which supports basically which supports BGP. That's it. So the kind of router which you're going to use should support BGP. That's it. So, and here there's no downtime. We also did without downtime also in static routing, but that was little like a hack. But some people dismantle the tunnel or tear down the tunnel and recreate it. When they do that, there's going to be a downtime. So please make sure you prefer to use, at least in your production environment, prefer to use dynamic routing. I'm not sure, not everybody will get this opportunity because if it's a migration kind of a stuff, then you may get a chance to do it. Or if it's on AWS to GCP, you may get a chance. But if you are going to work fully on GCP, totally new project, you may not even get a chance to work on Cloud VPN in your real projects. So depending on your projects, you may get to use, but prefer to use dynamic routing there. So that's about VPN. Now, slightly totally out of topic, but we will try to learn what is CloudNAT. Why CloudNAT all of a sudden? Actually, this slide should have come when we were discussing private Google access. At that time, we should have discussed this. I did not discuss that at that time because CloudNAT behind the scene requires a router. What is CloudNAT? We will try to understand. We know now what is cloud router. So we'll see what is CloudNAT. So let's take a very simple example to understand cloud router. Sorry. To understand cloud router, right? Let's take a very simple example. I have VM1. VM1. This VM needs to interact with Google Cloud Storage bucket to read some data. It needs to interact with, say, for example, GCR, which is nothing but again a storage bucket only. It needs to also interact with say, for example, MongoDB. MongoDB, which is not in GCP, folks. It is in mongodb.com. Sorry, mongodb.com, a cloud offering which they also provide. It is somewhere here. And it also needs to get regular updates, software updates. Maybe operating system, maybe something like, assume this is a Red Hat. This is a Red Hat machine. Red Hat has something called as satellite servers where they get some regular patches, all those things, something of that sort. So these are stuffs it should have, but a catch here. this VM should not have external IP address. It's like our senior management. They want everything, but yesterday itself they want something of that sort. They want all the best features, but they cannot provide external IP address for security reasons. Simple. For security reasons, they cannot provide it. Now, how do you do it? How do you do it? Now, if a VM needs to interact with Google Cloud Storage, what will you use, folks? VM is internal GCP resource. Google Cloud Storage is also internal. It's a internal resource. How can I do? So meaning the VM can only have internal IP address. What can I do to achieve this, folks? If it were to interact with the Google Cloud Storage bucket, how I can interact? Any options do we have? Last week we had discussed this. I can also make it still complicated. Cloud SQL. Yes, Vivek. So you can use private Google access, as Vivek and Anil Kumar mentioned. So you can use this option. Possible. We have seen it by ourselves. If you have forgotten it, please refer back to the last week's video. We had done this demo. Similarly, gcr.io. This is also same. I can access it. Now, if it's a Cloud SQL instance, how will you access it, folks? How will you access it? Assume the Cloud SQL instance is also having an internal IP only. This is also having a private IP. You will use something called as not a bastion host. You will use private service access, which is built in. We don't see it actually, but it's built in. We had also done this demo. That's the option which you get. So these are all going to be good. Now, because these were all somewhat related to GCP or Google Cloud, or Google infrastructure or Google Cloud itself, we were able to manage it somehow with all internal IP. But the problem comes when you want to interact with the outside world, the MongoDB, which is totally outside of GCP. Software updates, it could be n number of updates, or maybe I want to install a software itself, it may be somewhere outside. So in that case, without external IP address, it's going to become difficult. So to be on the safer side, what people do, this works even in on-prem, if I'm not wrong. So they do something called as network address translation, where they only have, what they do is, for the VM, they only have an outbound connection established to connect to your MongoDB, any software updates. If you want any software updates, you basically use this. So you want this to be put in the cheat sheet? Let me put it. Implementation cheat sheet. Okay, I'll just do the formatting later, folks, but I'll only from this IP only I'll connect. All those things you would have put. So if you want to do something of that sort, network address translation, cloud NAT comes very handy, where only the outbound connection is set up. The inbound connection is not going to be there. So from the outside world, people cannot enter your or access your VM. Only from your VM you can access your internet, everything. So a cool feature. So basically only outbound connection is established.
where implements outbound NAT in conjunction with your default routes. So this way, only the outbound connection is implemented, inbound is not done. So your VM or groups of VMs can easily access it. And cloud NAT basically, something like egress. Egress is only going to be maintained, and there's a huge networking concept behind the scene, folks. I'm also exploring for a long time. The usual standard question which I get, which still I have not got an answer. Let me be very straightforward and blunt in saying it. Normal person, right? When you understand this, so outbound, maybe somebody who has a good networking knowledge can comment it. I don't have that. Let me be very straightforward here. So a VM, this case, VM egress, it goes to MongoDB. Okay, so you can access it now. MongoDB has to send a response back, right? So meaning there's a kind of incoming request coming. So without that incoming request, how it works, I really don't understand it. They have a nice documentation, but I'm not getting that document understood. So I'm also spending some time there. uh, Explore it. They call something called as what is that called, direct NAT, uh, SNAT. They have something. So if you really come from a network background, you can definitely easily get it. I'm not from that background. So they have some concept like this, which makes it very clear. When you understand it, you'll definitely get it. Basically, the outbound connection is only implemented. I have seen in other trainings also, people ask, without an inbound, how the other MongoDB can interact with or send the data. There should be also incoming traffic, right? So they ask that, but I don't have an answer for it, a proper explanation, I don't have it. Some more networking concept is required, basically. I'm also going to explore. So once I get it completely understood, definitely I'll put a video in my channel. So because if you go search in YouTube CloudNAT, uh, one of the video which comes is my video, and one of the question which is also going to be asked is how without an inbound connection, how things work, for which I have not answered it. So if somebody knows it, can help us. But if you're not, no problem, explore it. There's good amount of room for exploration on networking stuffs. So now let's just see this part. So where I'm going to create a virtual machine with internal IP address. I will try to connect to my data Google Cloud storage easily. I'll show you that because of private Google access. But if I want to update a software or install a new software or want to connect to google.com or want to connect to anything else, I'll not be able to connect it. But the moment I provision a cloud NAT, I will be able to create it. Let me just show you. And this diagram, right, basically indicates if you have any update services, like for Red Hat, you have satellite servers where you get some updates. So since cloud NAT is a regional resource, meaning if you have a VPC and you have VPC which has 2 subnetworks or 3 subnetworks, one in Mumbai, one in London, one in US Central, and all the VMs using this subnetwork is going to need access to internet, but they cannot have external IP address. What you can do basically is have 3 NAT, one in Mumbai, one in London, one in US Central, so that all the VMs can access internet. Maybe they all needs to connect to MongoDB, which is outside of GCP. In that case, you need 3 cloud NAT, because cloud NAT is a regional resource. So in this case, you see one in US East, one in Europe, it's there. And specifically, there's a subnet where you wanted to give access to. You can give that only if it's from the specific range. Provide outbound access, otherwise don't provide it. So that's what they do it in this diagram. We'll see this in action by doing a small demonstration. So I guess I can close my project too. I don't need it. Gone. So if I just go back to my VM and close this, and also go to my VPC. Okay, if I go to my Taiwan, private Google access is turned on, meaning I can communicate with my Google Cloud Storage bucket, GCR, BigQuery, which we have not seen. Most of the GCP resources, except Cloud SQL and Memory Store, we can easily connect it. That's what we have seen. So let's just verify it one more time. Create it from a template. VM with internal IP. I'll change it to Taiwan. And the most important thing in this demonstration is I don't want external IP address. I don't want external IP address. Done. Done. Now, okay. It does not have an external IP address. Let me SSH. Without an external IP address, if I'm able to SSH, it's because of IAP. We already seen it. It is because of IAP. And because I'm the owner, I don't need any explicit stuff. It's going to work for me. But if you are not a owner, you should have IAP secure tunnel user role. Again, we have seen it. So if I just do gsutil ls, I should be able to list all the buckets. All these things is because of my private Google access. It is because of that. Now, if I were to ping yahoo.com, does not work, because one of the criteria for a VM to have internet access, basically there are three criteria. If I just revisit it now, it's really worth revisiting it now. Internet requirement. The following criteria must be satisfied for having an outgoing internet access. Must have a default internet gateway, which we already have it, because it's going to be created automatically. A firewall rules which allows the egress traffic, which is an implicit firewall rule, that is also going to be there. And one of the following three criteria has to be filled. So two are always going to be filled if it's default. If you create a custom VPC or a default VPC, it's going to be always going to be there. No need to worry much unless somebody explicitly deleted it. One of the most important rule is the instance must have an external IP address, or you must use a NAT. So since we don't have an external IP address, we are going to use Cloud NAT now. So what I will do now is, the ping is not working. Ping does not work. Forget about ping. I cannot even do sudo apt update. You see, it stops. It stops there. So it does not do that. So I cannot do anything which is related to internet. Anything related to internet. Let me just leave ping Yahoo and leave it like this. Let's create a cloud NAT and see how we create the NAT. And to explore more about how this inbound is not working, how it is blocked, all those things, I'll give you a small hint, which I'm still working on, but that hint was really helpful for me. I'll share you that also. Now go to my so we have explored some extent about VPC network, VPC hybrid connectivity. Now let's explore some more stuffs in our network services. Under network service, the one which we are going to explore is Cloud NAT. So CloudNet lets your compute engine, Kubernetes engine, container pods. Yesterday, you remember we had a private Kubernetes cluster and the pod was not able to get an update to install net tools because it was not having external IP address. So to communicate with internet using a shared IP, shared public IP address. The CloudNet uses NAT gateway to connect your subnet to the router, a virtual router that routes to the network. So you're going to use cloud router also behind the scene, and it's going to have an external IP address. So before I do anything, I wanted to show you this also. The cloud NAT basically also is going to have an external IP address, which is going to be static. So currently there's no external IP address, folks. Let me provision my cloud NAT. Cloud NAT is regional. By the time the screen loads, I'll add this in the cheat sheet. Cloud NAT is regional. Is also regional. So create this thing batch 6 NAT. Now to which VPC? For each VPC you need to add. My VM is created in VPC Taiwan. So I'm going to create a NAT there. And as we know, Cloud NAT is regional. You have to pick what is the region. So my VM is provisioned in, or my subnetwork is in Taiwan. So I'm going to use Taiwan. Now you need to create a router, and that's the reason why I did not share the when we saw private Google access not able to access outside internet. We could have discussed cloud NAT there itself, but we would not have understood how cloud router works. So that's the reason I had paused it. Now we know what is cloud router, so go provision it, and you should be able to do. And behind the scene, BGP is going to be used, very transparent to us. So there is nothing because we have deleted it. So I'm going to create one quickly. And here it's going to be very straightforward. So no need of a private ASN and all because it's going to be all internal. So they don't use it. Just give a name. That's it. Batch 6 NAT CR. That's it. Nothing else. Nothing else. That's it. You selected a region. You created a router. Now your network address translation mapping, how you want to do you want to apply it to your primary and your secondary ranges of all the subnetwork, or only to primary, or to a specific VM, individual IPs you can mention. You get a combination which you can do basically. So let's leave it as default. And network address translation recommended. So automatically assign a IP based on the usage. Manual static IP should be used before performing NAT. I'm going to leave it as automatic, which is the recommended one. That's it, folks. The destination is always internet. Destination is always fixed. That's it. Most of us, even I have done this in my video in the YouTube like this only. When you do this, your exploration is going to be a little limited. So to understand the cloud NAT, even which I'm trying to understand still now, but I have not got the complete understanding. One hint which I would say is click on this advanced option. By default, the logging is going to be disabled. So no logging because it's going to become more expensive. So that's the reason Google has disabled the logging. So if you want a better understanding how cloud NAT works, I would strongly suggest you to put this option, how the translation is happening and any errors in the logs, any errors during the translation. You'll get a complete picture there. You'll get a complete picture. So, and few other details. So I would strongly suggest to explore this advanced option. Many of the time we forget to expand this. The one which is going to help is basically this translation and error, okay, which I'm still exploring. Once I get it, I'll definitely share it with everybody. So that's it. NAT is going to be provisioned. So I'm just going to make something like this, folks. Where is my VM? Yes, something like this. So the moment I create my NAT, what's going to happen? I'm going to have an external IP address, which is not currently there. That's going to be my NAT IP address, which is static. That's something which is going to happen. And the translation happens. I should be able to ping outside machine. So if I just click on create, it's going to take around 30 seconds to do it. Done. The NAT is running. So we should see the ping working in a minute. It's working. The ping is working. If you want to do APT update, it's going to also get an update. It's going to also get an update. Done. If you want to install a software, let me see whether trace route is there. Not there. I want to install it. There. Now if I do, sorry. Now if I do, I see it. So I can do everything, but this VM will not have an incoming request from the outside world. So it's blocked. It's blocked basically. So very handy option. Very handy option. Now, since this cloud NAT is regional, tomorrow if you create virtual machine in the same VPC but in a different region, that's not going to have an outbound access. That's not going to have an outbound access. If you want to have it, you need to create one more cloud NAT in that specific region. Only then it's going to work. Okay. Now let me just show you the IP address which is going to be created, external IP address. Let me just refresh the screen. This is your cloud NAT IP, folks. This is the external IP address, and this is already reserved, and it is currently used by your router, is what it indicates. So this is fixed. Now, going back to the example which I had here. Now your MongoDB needs to be accessed by this virtual machine, but this virtual machine does not have an external IP address. The MongoDB, I can open it to the entire internet, which is really bad practice. But if I want to open it only to a specific IP, the IP which I'm going to whitelist your this IP, whitelist your cloud NAT IP so that you can access it. So this is going to be the option which you use. So you need to whitelist your cloud NAT IP. That way the MongoDB will allow you to communicate. So I have done this in one of the implementation. It works very well, this option. So it works very well. I'll just add this whitelist cloud NAT IP. So this is how you usually do with all internal IP only. Now you see you don't have any requirement of having an external IP address itself, unless the VM you want to access it from the outside world. Maybe some web application is running, you are going to have an IP address, you want to access it. That is also going to be removed totally when we see it in our next class, where we are going to talk about load balancers. So literally the thumb rule is individual virtual machine should never have an external IP address, folks. That's going to be the best solution which you are going to provide to some customer. I'm just going to mention that in the cheat sheet. I'll do the formatting later. A compute engine should never have a external IP address. All other stuffs I can provide should never have an external IP address. Is the best option. The best option. Everything I can fulfill with the help of IAP, a private Google access, private service access, cloud NAT, everything with load balancer, I can fulfill that. So we will see that kind of a demo in our next week where we will learn about load balancer and we'll see a virtual machine with no external IP address, how we can make it work. We'll see that. But make this as an option. And I follow this very strictly in most of the implementations which I do. So it's not only for virtual machines, even for Kubernetes cluster, I do this. So that way you are already having a security layer built in. External IP address is always going to be risky. Plus the cost is also going to be there. Cost is also going to be there. From last year, June 2020, every time when you create a virtual machine with external IP address, there's a charge. Previously, there was free. So from June, they started incurring it. That the cost is around $3, $3 US. So why do you need to have that? Basically, you don't need it. So you can have a lesser cost by using Cloud NAT. Basically, that's the key part with Cloud NAT, folks. Apart from that question, how that inbound without it works, any other question I can answer it about Cloud NAT, because even I'm exploring it for a long time. I could have asked that in some forums or anything. I'm not sure whether I will get a response. So, but I'm exploring it because when I only explore, that happens to everybody. When you only explore something, your knowledge gain is going to be too much. Instead of somebody saying an answer right away, it's going to be narrowed down. Maybe by the time I explore this answer, I would have got some more exposure on networking. That's the only reason I did not even ask. I have few access where I can ask few of the Googlers, because I have some connections, LinkedIn connections. I can ask them, but I thought, okay, let me only explore it basically. Okay, so slightly out of topic because after VPN, we should have discussed interconnect. We did not discuss that because we directly jumped into cloud NAT, which was totally out of topic, but it has a connection with our cloud router. I thought of discussing it there. Now, cloud VPN is really a good choice for GCP to GCP or GCP to a non-GCP network, and quickly, if you wanted to implement it, this is going to work very fine. But one of the drawbacks of cloud VPN is the communication is over public internet. Don't worry about the security because it's an encrypted connection. But the problem is, because it is over public internet, the latency is going to be very, not very reliable there. So it's going to be also limited. 3 Gbps is my understanding. Vivek mentions he saw something, it is like 12. I will also verify it. But it's a limited bandwidth is what you get. And you cannot expect it to be super fast because it's over public internet. So if you want a better network bandwidth support, then every cloud provider provides you something called as direct connection, dedicated internet, dedicated interconnect in GCP, direct connection in AWS, express route in Azure. So what is this basically is, the diagram explains that you have on-premise. Now, assume, I guess most of you are aware about the locations in India. So I can take India as an example in this case. So assume you have a on-premise, you have your office, your data center is in Mumbai, the hub, the central hub of India. So it's in Mumbai. This is your on-premise. Now, Google also has a edge point of presence in or a co-location facility. They have a data center in Mumbai. Now what happens is, from your data center, you're going to connect directly to Google's data center using a VLAN, a virtual LAN. By doing this, what happens basically is, you're already connected to Google network. Now, from your on-prem, maybe you have another center. Maybe you have some VMs provision in US Central. From Mumbai, Sitting in your data center, you can access your central machine using internal IP address, and the entire communication is using Google's optic fiber network. So only from your on-prem to your co-location facility or the point of presence, you are going to use your own fiber there. Remaining everything is going to be Google's network. So this way you can get a very high bandwidth support. It starts with 10 Gbps, and it can go up to 200 Gbps. 200 Gbps. So very high bandwidth support can be provided. That's basically your interconnect. But the key part here is you need to be in Mumbai. Your data center should be in Mumbai. At least if you are in India, or it should be in Chennai. Why? I'll show you that in a minute. If your data center is in Bangalore, or if it is in Noida or in Delhi or in Hyderabad, it's not going to work. Why? I'll tell you in a minute. Before we go to that, I wanted to show you a nice diagram. This is again taken from the documentation only. Dedicated interconnect. I really like this diagram. Why? Is because it depicts it completely the details. So this also behind the scene uses BGP. Remember that. So you have your GCP this side on the left hand side. You have a network, a subnetwork in US Central, which is 10.128.0.0/20, basically the default VPC. You have a VM which is going to have 10.128.0.2. Now you have a cloud router configured, link local IP address is configured. On the other side, the beautiful thing is they have class C. They have an on-premise router. The highlight of this entire diagram is this on-premise router, folks. It could be Cisco, Juniper, anything. So, which is BGP compliant. It is going to have a link local IP address. Now, this router is going to advertise all the route information, the subnets, all those things from this on-prem. This cloud router is going to advertise all the information from the GCP side. Now, there's going to be a co-location facility, actually an office or a data center kind of a stuff, where these two networks are going to be peered. Once they peer it, this VM, I can open up this VM, SSH into this VM, and do ping 192.168.0.11. If I do it, I'm going to get the response, and the round trip time is going to be very less. It's going to be in few milliseconds, because the entire communication is leveraging Google's optic fiber network. That's the key part, and I really like this part, which gives that completeness. Yes, you need a cloud router on both the sides. Sorry, you need a router on both the sides. In GCP, it's going to be cloud router. In on-premise, it's going to be something like a Cisco or a Juniper router, which is BGP compliant, basically. Now, let me just show you a small demonstration of dedicated interconnect. I cannot show the complete demo because it's going to require some paperwork. You cannot do, even if you are the best organization with the lots of money, with all the connect, you cannot do that, because there's going to be some manual work involved, paperwork involved, letter of LOA, letter of agreement is going to be there. So somebody needs to sign all those things. So in the exam, if you get any questions where you need to quickly have a connection between on-prem and GCP, AWS and GCP, dedicated interconnect, or basically there are two versions of interconnect, dedicated and partner interconnect. None of these things are going to be a possible option, because quickly I cannot set it up. Minimum 5 days is going to happen, minimum 5 working days. So quickly, if you want to do, cloud VPN is the only choice. Why? Let me just show you in the demonstration. So if I just I can just delete this VM. So if I go to my hybrid connectivity, interconnect is going to be there. Dedicated interconnect. So interconnect lets you establish high bandwidth, low latency connections between your Google Cloud VPC network and your on-premise infrastructure. and it is only between GCP and on-prem, folks. Simple. There's nothing like GCP and AWS. It's not going to work. GCP and on-prem only. And you get these two flavors very nicely depicted. Dedicated, where from your on-prem, the next hop is going to be GCP. But in some cases, the example which I mentioned, if your data center is in Bangalore, Hyderabad, apart from Mumbai and Chennai in India, you have to use basically a service provider. You have to use a service provider. Why? Because your data center is not very near to Google's co-location facility. So if it is in Mumbai or in Chennai, it's going to use directly a dedicated interconnect. So I'm going to use dedicated interconnect. I need to also order it. I don't have any setup. Let me click on order a new dedicated interconnection. So first and the foremost part is give a name. So I'm going to call it as dedicated interconnect DIC batch 6. Yeah, batch 6 should be good enough. Now choose your co-location. This is the location which is important, folks. Now in future, when you're going to implement a dedicated interconnect for any customer, first come here and check whether the customer's data center, ask where is their data center. Come to this place or look into the dedicated interconnect documentation and see whether you can address it or not. For example, if my customer is in Mumbai, I'm just going to come, put a filter, search for Mumbai. I'll come to know there is two facility available in Mumbai. One is from Tata IDC, Tata Mumbai IDC, and another one is from GPX Mumbai. So if you want to know the details of it, where it is available, all those things, complete address is going to be provided. So people who know Mumbai will be able to know this address. So this is the complete address. Similarly, GPX, it's there in your peering DB website. You can just go and you can completely know the details. So find out how far is your data center from this location, how far it is from. So will there be any difference if we use multiple projects, use this network? We'll come to that, Kumar. So slightly advanced question. Next week I'll answer that part. So first we'll understand this part, then how we can use another project here. Should be for every project, should we have dedicated interconnect or not? We'll see that part next week. Okay. First we'll finish this part. So similarly, Mumbai. Now if I'm in Bangalore, if I put a filter, instead of Bangalore, I'll put Delhi. If I put Delhi, I don't see it. Oh, Delhi came up. Okay, Delhi is there. I was not aware, folks. Oh, SIFI, Red Fort. Okay, a network issue. Sorry. All of a sudden, my router got restarted. I guess you are able to hear me back, folks. You're able to hear me, right? Yes. Thank you. So sorry. I don't know what happened. I'll try to fix it later. So if I just put a filter on basically Chennai, I will get basically two results in Chennai. Bangalore, I'll not get it. Bangalore, I'll not get it. So at least in India, including Mumbai, including Delhi, you have 3 co-location facilities available. Similarly, if your customer is in London or something, make sure you see whether they have a presence. They have a presence, then only propose this. So I'm going to use Delhi, the new one. I'm going to use SIFI. That's my co-location facility because my data center is very close. I'm going to use it. Now, the beauty of this one is the capacity which you can get is going to be really mind-blowing. It starts with 10 Gbps, folks. Starts with 10 Gbps, and each link is going to be one link is having a capacity of 10 Gbps. You can have multiples of this. So you can go up to 80 such links, which is going to give you 80 Gbps, or you also have a link which is 100 Gbps capacity. So multiples you can do. So you can go up to 200 Gbps. So choose that, choose one of them which suits your requirement. I'm just going to use 20 Gbps. Then click on next. Now, dedicated interconnect provides you a SLA of basically provides you an SLA of 4 nines. If you don't rely on a redundant network, what's going to happen your SLA is not going to be covered. So if you say I don't want a redundant network, your SLA is not going to be there. So you cannot raise a ticket and say that, or there's no compensation which they are going to give if there's a breach in SLA. So if you say yes, let me have a redundant network, then you copy it. IC batch 6 to second network. I always prefer to use the other one. SIFI is my main. Second one is going to be my Tata Communications Delhi. So that way, if you see 20, so totally I'm going to get 20 Gbps and I have a redundant network. So one connection itself is going to be $3,400. So because I have redundancy, it's going to be double the cost. So I mentioned my co-location facility. Click on next. Then here you have to provide your company details where there's going to be a letter of authority will be sent. There's going to be some mail conversation happening. Then only the setup is going to complete. So I cannot go further beyond this. I have to stop it here because it requires a company name, contact details, all those things. So your here the contact details, it should be basically the on-prem network engineer group, network engineering groups email ID. That's going to be the best way because they are going to be the one who can give such information. There's going to be a engineer from Google who's going to contact this, and once all the necessary information is going to be shared, they are going to enable it and the connectivity is going to be built. So this is how it's going to happen with dedicated interconnect. But if your organization is not in this co-location facility, if it's in Bangalore, which is not going to have a co-location facility like this, then they have to rely on a partner. They have to rely it on a partner. So partner also can provide sub-rate bandwidth. There is some range which they provide. We'll see more on that in next class. So partner interconnect is also possible. Maybe if I have a data center in Bangalore, I connect from Bangalore to Chennai because that's the closest one for me. From Chennai, there's a dedicated interconnect. The partner provider the service provider is going to do that for me. So two options, but when you are working, and very few people will get an opportunity to work on this. So dedicated interconnect, because it's product wise, it's expensive. Bigger organizations only can afford it. And if they have such requirement also. So not just because they are big organization they are going to use it, but only if they have such requirement, huge amount of data needs to be transferred in and out every day, only then they are going to prefer it. I had a chance to see it only in one of my consultation opportunity, where it was for a Belgium customer, somewhere in a Belgium customer who was doing some F&B sector. So they had a dedicated interconnect, and I had seen the person was able to open up the laptop, ping from his laptop, and was able to reach to the VM machine in GCP. It was really good to see that part actually. So very less people get an opportunity to work on this part. So we'll stop it here, folks. We'll talk more about dedicated interconnect, comparisons, all those things in our next class. So we'll stop it here. The next slide which we are going to do is basically a comparison. So I cannot do a complete demo on dedicated interconnect because it requires an organization, all those things, which I don't have. So, but the key part is whenever you have more bandwidth requirement, dedicated interconnect could be a good choice. And dedicated interconnect choice comes into picture only if you are very close to Google's co-location facility. Otherwise, it's not going to work. You have to rely on a partner. So let me just stop it here. People who have a hard stop can drop off. So if you have any questions, happy to answer for the next few minutes. Any questions, folks? Are you still working on the Terraform video? So not getting time actually, Deepak. So I'll work on that, Deepak Pandari. So still working on it. So did few implementations. So but there's one video which I already recently created it. You can see that could be helpful. A little bit of a reverse engineering, Deepak Pandari. So where for an existing resource you can create a Terraform template and use it. Look into the in my channel, YouTube channel, you will get it. So it was last week or last week I had posted it. So the last recent video, so where that could be an option there. But I'm planning to have something more by May end. I should start. Sorry, from May 1st I should start something better. Because of an implementation I'm stuck. Okay, folks, looks like no questions. People are logging off. Have a safe week ahead. See you next week with more concepts on networking. Okay. All right, folks. Thank you. Bye. Let me stop the recording.